Okay, so I think we can start. First of all, nice seeing you. I see many familiar faces. I'm happy about that. And today we will talk about natural language generation, okay? And there's the term advanced. Advanced doesn't mean that we are gonna go overly technical about it. Just is like we assume that you already know a little bit how things works, and the goal is really to understand how to use these type of models, this type of generation, okay? So we are gonna be doing something that from like a technical point of view is not that difficult, because we are gonna be talking mostly about prompting, things that go wrong, so hallucination, biases and so on, but especially where you would like to apply the techniques that you have been seeing with us in the winter school and you saw also yesterday, you really need to know what you're doing. You really need to know what could go wrong, okay? So today it's mostly gonna be about that, and that's gonna cover probably the first half of the lecture. Then, in the second half, we are gonna be doing something a little bit more technical, but very exciting, because we are gonna touch upon fine-tuning, which is a technique that allows you to change somehow the models. So the first part is going to be, okay, let's understand what are the good ways, how should we interact properly with the models, what can go wrong, and then we are going to try to change the model ourselves, okay? And there are going to be a lot of notebooks, interactive things that I would like you to try. I uploaded almost everything on the shared Google Drive folder. I think you can see it. If you go under advanced, day 2, there should be the presentation that I'm showing you. On top of the presentation, there is another file that now it seems something strange, but then I'll tell you what it is. And then there's like a small folder called notebooks, in which there are all the notebooks except one, because I still want to do a small change before presenting it to you. And so let's get started. Roadmap, okay? Let's start with the detailed timeline of today. First of all, we are gonna just, say a few words about what you have seen yesterday, and I would like to just fix some ideas, okay? Because I've been doing a lot, but I want you to remember, and I want those to be crystal clear, a couple of concepts, okay, about what you have done yesterday, because those are always important to remember. Then we are going to see how generation actually works, okay, because we are not going to go too technical. We will stay at a high level, but at a level that it's very important to understand then when you are doing something, why you are doing that, okay? So really, okay, generating language, what does it mean? How does it work, okay? And then, as I was telling you, the two blocks that, I really liked myself preparing the material are that of controlling the generation, because we are going to be generating text. But, how can we steer the generation towards whatever need we have, okay, whatever thing we want the output to be? That's going to be very important. But then, especially if you are sloppy, and usually we are, especially me, when I'm prompting, I tend to be very quick and dirty, try to do it fast. That's the wrong way of approaching the thing, okay? You should really be mindful of what can go wrong. So we're going to talk about hallucination, biases. There are a lot of biases. Then there is going to be a point in which, I provide you an example, and then I want you to try it out if you can find some more. And then maybe we collect the biases that we have found, and we are going to discuss them together. Then I told you, it's going to be a slightly technical part. I will guide you along, and the code is very simple there, and that's the beauty of that. But doing transfer learning, it's going to be fun, because it's like you're really going to feel, okay, now I'm really working on these models, I'm changing things on this model. And I'm not 100% sure that we will be able to do that, but anyways, it's going to be like a very high level introduction. You already heard about attention, and I will just tell you something about interpretability. I will just tell you some simple things there, because that's also an active field in computer science. So the computer scientists haven't figured it out yet themselves. So before discussing too much about that, it's better to know that that exists. There is some work that has been going on for some years now, but I mean, still very challenging things, okay? But we are going to discuss it as always. You know, the ideas are important. Then the details, I mean, they matter, but I mean, it's better to really have crystal clear all the ideas, and that's it. I mean, when you know which are the tools available, what you can do with those, I mean, you're done. You can really use it and apply it whenever you need it to your research, to your work. Okay, so let's get started. Let's say the bridge from day one, just picking up some ideas from yesterday and trying to, you know, have them settle with you, revise them together and just say, okay, I'm done. I know that. I'm sure about that. So, I don't know if Giovanni presented it this way, but I think in a similar way. When you use language models in general, you have at least two macro categories, okay? One is natural language understanding, okay? And the other one is natural language generation. Okay, what does it mean? Well, the first category is primarily concerned with BERT and those type of models that I'm sure you have seen yesterday. And that, I mean, if you should ask a question to yourself about, okay, what's all this thing about? The question is going to be, what does this text mean? So it's really understanding. I mean, the key word it is not really in natural language, because you see you have an L in both of the acronyms, but there the understanding means, okay, BERT-like model, for example, take a text and the goal is to try to understand, construct a representation of what the text means. But I told you, today we are going to do generation, right? Generation is something else, okay? Of course, there needs to be some kind of understanding, because if you're not understanding what, I mean, you need to generate, how can you generate something? But the end goal there is what should come next, because you are generating. So the first one is like, okay, I have a piece of text, I need to try to understand what does it mean, which are the relationship between the words, what is the context, and so on. The other one is like, I have something, what should come next? So today we are gonna deal about what should come next, okay? So we are there, focusing there. Just, you know, to do some, to do a summary of what you have seen yesterday. I'm sure that you have seen these models. So you have seen BERT, or, you know, slight version of it. There is Distilbert, Roberta. There are, you know, the good thing about computer science is that usually people do stuff and then they provide them for the public, okay? So you can use them. And there are a lot of these type of models, and these are called encoder only, okay? You might have heard that. What that really means is that encoding means really understanding, okay? So as I told you, we have natural language understanding, and those that family of models, the end goal is really to understand what the text says. And usually, I mean, here you have just a definition. You have to read whatever text you are taking and try to make sense of it. And this is very important part, okay? Because different families of models are usually used for different tasks. So this type of classification is not just for saying, yeah, we have this, we have that, but then doesn't really matter, it's all the same. No, here, these encoder-only models, when you need to do understanding, used for classification, name entity recognition, there is just an acronym to say, okay, I have a text. Inside of that, I have my credit card number and my security code for the card. Well, I don't want to disclose that. I want to have a model that masks it. So recognize the entity and says, okay, there you have a credit card number. Do you want to keep it or not? Okay. And to do that, you really need understanding, right? Because you need to understand, okay, maybe whomever wrote this piece of text is leaking the card number. And so you need that understanding, and you can use those bird-like models, okay? And of course, you can do sentiment analysis. I remember some of the groups in the winter school did sentiment analysis. Well, you likely used a kind of encoder-like model. There are many more. You can do sentiment analysis in other ways, but still, if you can understand the sentence, then you can say, oh, well, this is positive, neutral, or negative, right? And then you have GPT. I think you have seen GPT-2 yesterday, and that's a decoder-only model. Decoder means, encoder was building a representation and understanding. The decoder is like understanding the context and then continuing. Okay, so this is all about generation. So here we have understanding, there we have generation. And of course, the usual tasks are a little bit different because here you use for chats, right? If you understand something, you cannot really answer it. You need something that can generate. So the generators, you can ask something, they are of course able to understand what you're asking, and then they are able to answer you. That is really what happens with GPT and all those models, Gemini and so on. They understand what you're asking and they are able to generate text in order to answer to your whatever problem questions, okay? You can do translation, you use for code. Remember when you are on Colab, if you have the auto-completion on, you just, start writing your code and then magically it appears, oh, maybe you want this line. Okay, that's generation, right? Because knowing from what's above, you can continue what you want probably to do, right? And then you have models such T5 that you have seen as well. And really what it is a combination of the two things, because here you see, this is an encoder only, this is a decoder only, this is an encoder-decoder, okay? So it's something that puts together the two previous words and first try to build a representation, an understanding, and then generates as well, okay? Usually these are kind of more popular, but in some instances, especially when you have tasks in which you... Sure.
I'm sorry. I was wondering how translation is a decoder only, because isn't it supposed to understand what the text means and then translate it?
Thanks for the question.
Generate a new text. Isn't it T5?
Yeah, you can do with both. You can do with both, because here, imagine, here you can really think of it like ChatGPT, okay? There, anyways, when you are prompting, when you're writing your, instructions, those are understood by the model, are encoded by the model, but it's the task that is different. There, of course, you need understanding in order to continue. We are gonna see how generation works, right? And so there, you use that a lot because it works very well. But from a, let's say, theoretical standpoint, it seems strange, as you are pointing out, because, well, I should need a representation, understanding that I need to do a translation and then translate, right? So it seems something that you should do there, right? But actually here, these models are so well trained to even understand what you want to do, that if you say in the prompt that you would like to do a translation, well, the model, if it is big enough, okay, we are going to go into those details later, can understand that the next token should be the translation of whatever you provided. So really, it seems strange, but think of it this way. If you are always able to know what should be your next word, you are able to do anything, right? Because if I ask you, please translate me in Turkish this sentence, how are you? You exactly know what is the next word that is going to come up, right? So even though, it's like more suited for, you do translation perfectly with this. Also, you're going to see, and that I did it on purpose, with these models, you can even do classification. It shouldn't be the case, but if you ask the model, hey, I have these labels, football, basketball and volleyball. Tell me if a text is talking about any of these. Well, you can do that. It's not really the best thing you can do, and we are going to see why. You should be using for sure something that understands the text, but still, if you know what comes next, you can go on as much as you want.
In T5, it is only the text, or it could be visuals, audio, whatever?
Well, T5 is text. I'm sure that there exist, I'm not the maximum expert of multimodal or vision transformers, but there are the same kind of models that act with any source, so audio, video, images, even combined. There are models that combine those things together. So they exist, but since the spirit of the school is on text, we mainly focus on text. But there exist such models.
Okay, then I have a very simple follow-up question.
Yeah.
Let's say I have data on text, 2 pages data.
Mm-hmm.
Could you tell me, like, if we use like BERT, what will happen? If you use GPT, what will happen? If we use T5, what will happen? Like, what are the differences when we use this? We analyze these 2 pages.
The question is what you want to do.
Let's say we are going to. It's a qualitative data. It's from the interview,
Mm-hmm.
and we have a research question that we want to answer. Okay, we want, for example, it's a life trajectory. Let's say it's about one person's life trajectory, how that person is living the religion. Okay,
Mm-hmm.
we want to understand, and then he talks about, like, the participant, or he or she talks about experiences, like what are the reasons for her, and explaining the situation X, Y, Z. So I want to explore it. I don't know what is there, but I want to explore it. I want to see it. If it's 20 pages, it's 100 pages. 2 pages is easy. Even I can do manually.
One exercise that we are going to do today, always, regarding this part, it's going to be, I have some text, and I want you to extract who are the actors involved, when whatever event happened, and where. So, I mean, it's not exactly what you're saying, because what you're asking is more complex.
Quantitative. So it is like, mainly, I don't know, we are social scientists, and we also deal with the qualitative data.
Mm-hmm.
Like, these are very quantitative things. Okay, we get this number, this number, this number. But qualitatively, how we are going to benefit from it?
Probably I'm a bit skeptical about that, because I think that the qualitative part is the one that a scientist needs to do, okay? I think that can assist, because, maybe you understood, right, how this model works. Those models are very large models who have read everything. I mean, the way in which they train those is like, okay, I give you the entire Wikipedia, I give you the best research articles that are there, I give you all the top blogs in the world, read them in some sense, and try to make a sense out of them, okay? So if you ask whatever question, they will provide you something. But I think that your judgment there is the key. And your judgment, you only have that. These can help you focusing. For example, if you have, instead of 2 pages, you have 100, you say, hey, please tell me the pages in which the life trajectory of a person is the dominant topic. You can do like that. So instead of reading 10 pages, you read 2, and then you can do your qualitative research. Okay? I would not, demand to these kind of models doing the qualitative part.
Okay, then here's coming my question. These things all that we can do with the ChatGPT, Gemini, whatever, or Mosquito, no, they have AI assist. But in this training, what specially we are going to learn to do this kind of analysis? Like, we are already doing this.
Yeah?
I can only do the Gemini or use the ChatGPT as a language models, and I can give the prompt, and they can give some ideas based on my data. But especially what in this training?
Today,
what differently we are going to
you're
learn?
gonna stay here, right? You're gonna stay here till the end.
Like, how we can benefit, like, with training to do this kind of analysis, or it will not be helpful.
It's a difficult question to answer, because it depends on what you are doing. For me, I use them every day, for example, and I'm sure that if you do sentiment analysis, you're gonna use these a lot, okay? Because you have 1 million tweets, you do sentiment analysis. If you need to do translation for one language to the other, because you have a new PhD that only speaks English and you have policy documents in Turkish, okay, you can use T5 to translate them. If you want to label some data, because there's going to be a silly example on some sentences which are going to connect it to, okay, this is protest, this is not protest. You can use these models to tell you, okay, this text is talking about protest thing and not. So there's plenty of things. I cannot think of one thing that you won't benefit with this kind of stuff.
I'm saying we are only doing this kind of things.
Yeah?
With or, like they say, limited knowledge of AI. Not AI, we're just using the prompts. But what specifically differently we are going to learn by learning these things? Like, we'll get the logic only behind it? I'm just wondering.
What do you want to know? What do you mean? The logic behind it, what do you want to know? How the mechanism technically work?
Like those things that you mentioned, I'm sure maybe I misunderstood, or I cannot say it clearly. Those things that you're mentioning, we are already, in a way, managing by just prompting.
Mm-hmm.
But I'm sure there is something rich here that if we learn, we can do something that we are either doing wrong or in a better way.
Yeah, I mean, this is the lecture of today. I told you, you know, in the timeline, I told you the most interesting part of today is going to be how do I control the generation. We are going to take some examples, okay, and we are going to see how the output will change according to how we instruct the model. I told you, me, but many people, when they are writing the prompt, you always do it quickly. You don't really think about how should you structure it. So today we are going to structure it together.
So
there's going to be
prompting.
that's one part. But then also what goes wrong. I mean, because then if you just rely on that, I mean, the big problem with any type of model that seem, you know, to know everything is that you rely on whatever the model tells you, but then it's going to be messy. Because, for example, we are classifying the sentiment. We want to have positive, neutral, and negative. And then the model at some point tells you, I don't know. I mean, it's generating. Probably the most probable sequence after that is, I don't know. But you have to manage it. But if you don't know that that can happen, you will never catch that mistake. So we are going to all see that, and then after that we are going to say, okay, now I have one model, and I have one very specific task that only I have. And my model is general, can do anything, but I want the model to do what I want it to do. And we are going to see how to change the model in order to do your task, whatever it is. That works for any task, okay? And yeah, more or less, okay. So, as I was saying, today we are just going to focus on the decoder models, okay? We have done a lot about this. You have seen some example about the encoder-decoders to do translation, for example. But today we are going to use GPT-like, okay? And so we are going to generate, and we are going to understand how you understand which going to be the next token, what should come next, okay? So, first thing first, when we are introducing a new concept, we first have to say, okay, what is it? Okay, what does it mean? Actually, the definition is embedded in the name itself. So when you do natural language generation, you want to produce fluent, coherent text. Okay, that's the best thing about this model, but it's the biggest problem, right? Because some people in my country say that if you say something wrong, but you're confident while saying it, all the room will accept what you're saying, right? This is the problem with this model. I mean, some of the things that I'm telling you today will help you in understanding when the model is not that confident, okay? We are going to see some mitigation strategies because, you know, prompting ChatGPT to say, okay, tell me whatever. You say a task, you write everything there, you put all your data inside, and you say, give me the answer. Well, that's the worst way of doing it. You first need to understand, and we are going to do it together, how you should do it properly, and then how to critically see at the results, okay? So, the goal is like, I want fluent and coherent text, but really what natural language generation methods do, they all do one thing, understand what the next token word is. So, if I have this sentence, the cat is on the, okay, my model will probably say sofa, table, whatever, okay? And that is not it, okay? Because you need to continue. I mean, the sentence does not end there, right? The cat is on the sofa. What these models do is like, okay, they take this new part, they have generated the word sofa, but then they need to go on. And so they take this part and they say, sleeping, because the cat is there sleeping. So all this part of generation is going to be about understanding, okay, I have something, how should I continue? How should I continue? How should I continue? Okay? And if the model is powerful enough, you can do basically anything, okay? Because the model has the understanding of okay, I'm talking about the cat is somewhere. Where could the cat be? Okay, the cat can be on the floor, can be on the sofa, can be on the couch, can be outside. And then the task is like to understand, okay, which of these words should I select? And
can I ask a question?
Sure.
Maybe this is, I don't know if this is technical, but how does the syntax of like sentences emerge with these models? Because do they have like explicit instructions to give like grammatical sentences, or does it emerge naturally? Like,
You mean the correctness, the grammatical correctness of the sentence?
I mean,
Good question.
It doesn't give a like bunch of words like just by like similarity or prediction, but gives a like grammatical sentence.
This is like a good question, because I prepared for you later like a small dashboard to play with, and I made it on purpose very dumb. And you're gonna see that when you try it, you know, it's very repetitive. It says at some point, if you tweak the parameters, it say the cat is sitting on the warm sun, because you know sun can be warm. So it, you know, a little bit it's not that smart to understand that a cat cannot be on the sun, but that I did on purpose. And in that case, I mean, you have kind of the structure that is okay, but you are saying things that do not make sense. With large language models, the structure, the fluency, the correctness in the grammar emerge from the training. So these models, training a model means, okay, you have an architecture, okay, you have some, you know, those are kind of technical things, are always neural network, attention layers, and so on and so forth. But imagine it as a black box. You can imagine it as a small child, okay, that does not know anything. And the task may be whatever. For example, reading. What do you do with a small child to read and then to be able to write? You give it many text, maybe simple, okay, you start from simple things, you say, hey, this is A, B, C, D, whatever, and you start reading with the child and you teach, okay? So the model learns, the child learns. After that, since these models are large language models because they are trained on anything, imagining being able, as a human being, to read the entire Wikipedia. I mean, if you have read that, you kind of know everything, first of all, but not only that, you know how to write properly, because people there, they are good writers usually. They do not write, you know, like maybe a blog post that is done by somebody like me that is not very good at writing in English, and you know, it's a bit not that polished. But there, when you have high quality data that the model can read and can learn from, then you speak perfectly. And as I was telling you, this thing is emergent from the training. And this is the best thing of this model, but the worst problem, because it always seems that they are right. I mean, whatever they tell you, they put it in such an authoritative way, and good English, or whatever language you are using the model with, that you are like, yeah, but this should be right, you know, it's so neat. And that's the problem. I mean, that's the goal the people that have been developing this model had, so to be fluent, to be natural, to understand the grammar by reading everything, okay? And we are gonna see how we can trick them, how we can see strange things, but definitely to answer the question, the correctness, the fluency comes from the training. Okay, so it's something that it's already embedded in the model. Okay, so as I was telling you, with natural language generation, you actually can do kind of everything. Not always is the best thing to do with these models. There are things that are better done with these kind of models. There are other that, I mean, better use, for example, BERT or T5. But, for example, you can do summarization, and we are going to do something like that, because I told you we are going to be seeing an example in which, okay, you have text, and you want to extract some type of information, so you can do kind of retrieval of things. You can summarize long passages. You have a really long piece of text that, you know, you already know it's a little bit redundant, and what you can do, it's like, hey, you are my assistant. I want you to summarize, retaining all the relevant information, this piece of text, okay? And you can do that. You can do Q&A, dialogue, and so on. The first hands-on session in Python, it's gonna be a small chat with which you can interact locally on your PC. I mean, of course you can do that with ChatGPT and Gemini, but many times the problem is the cost. Here, today, we will learn, okay, I will take an open source model that it's there for the community to use. We are gonna download it together, and we are gonna use it on Colab. You don't pay anything. You can use it as much as you want. You can go on, ask anything, whatever. When I first do it 3-4 years ago, when I started learning language models myself, that was really exciting because I was able to download a small model. We are going to do that together, and you can ask basically anything. Of course, it's not in answering the question as good as ChatGPT. Why? Here or on Colab, you have your small infrastructure, and I mean, OpenAI as another type of infrastructure. But one of the ideas that I want you to understand after today is that if you know your task, and you can tell the model which is your task, you don't need the biggest model in the world, okay? Because ChatGPT can do anything. You know, you tried. I mean, you give it a table, it gives you a description of whatever is inside the table. You give an image and it tells you, oh, there are 2 cats, 1 dog, and a giraffe, okay? I mean, something that can do everything, it's not good at doing everything. It's kind of good at doing many tasks, but not excellent in something. For example, when we will be doing fine-tuning, I told you, we are going to tell the model exactly our task, what we want to do, okay? So this is something that you need to keep in mind. And then you can, of course, paraphrase and rewrite. For example, I do that a lot because I told you I'm not the best English writer in the world, not at all. And so I usually provide my passage in which I have, you know, my ideas, my points, and so on. I provide a prompt in which I say, hey, do not change the content. I don't want the content to be changed, but please make it fluent. We had just discussed that fluency is the thing that they are best at. So use this model to, you know, have a better looking text when you do whatever you need to do, an article, a report, a paper, okay? And then this one I will not touch because I think the 4th day or the 3rd, I don't remember, you have an entire section on that. You can generate data, okay? Yes?
I think it was about paraphrasing and rewriting mostly. Just my suspicion and my instinct. Avoid editing my text using Cloud or ChatGPT for fluent English. I keep my text manually on side and I'm doing changes partially because my suspicion is with this rewriting and paraphrasing, the whole text can sometimes change a little bit. So then this is my suspicion and I don't have any proof.
No,
I'm going to check this could that be possible?
Definitely. What I want to ask to you is, like, usually when you do that, what do you write to ChatGPT?
For instance, I'm taking 2 paragraphs of my writing.
Yes.
And I'm creating more coherent.
No, really, what, I mean, on the chat, you copy paste the passage.
Yes.
You copy paste the passage and you say, can you rephrase them for me?
Yes.
Okay, that's the problem. I mean, that's the main problem. But we are going to see today, I mean, it's normal. Everyone does like that, everyone. I mean,
so for the last 3 weeks, I'm avoiding my text, manually working on my text on a Word document, just having conversations for editing or, you know, correcting my English grammar-wise and copy-pasting back to my manual Word document.
If you do, you know, well, we are skipping a little bit ahead, but I think it's important to answer, and then we are going to repeat, so, you know, it really stays with us, the concept. The problem there is that you are too vague. I mean, you are rephrasing, but the model has its own way of seeing at the sentences in some sense, okay? So, I mean, if one word that you have been using, the model thinks is not the best, the model gonna change it. But if you tell the model, and that it's what we are gonna learn when we are gonna see prompting, you can tell the model, hey, I want you to rephrase this just to change the fluency, but do not change any content of whatever I told you. I mean, the task is the same, but you are more structured in what you are asking. Then again, you don't have the guarantee written in the stone that it will not change some of your stuff, okay? To me, for example, because of course I work a little bit more with numbers, but sometimes what happened, it's like I had, I don't know, a number that was 92% in my small paragraph, no? And I gave it to, I think, ChatGPT, and I said, please rephrase it, do not change the content, and so on and so forth. And then I saw 91%. Hey, my figure was 90%. But you know, when you observe that, what you can say is like, hey, whatever number you encounter, do not change it.
Is it also a possibility that my changes in other places that I'm not asking for paraphrasing or corrections?
Other places, what do you mean?
In the text.
Well, if you ask to paraphrase a text, it may change all the text that you are giving.
No. Think about this. Like, I upload my Word document on ChatGPT, so it reads all the text, my article, and I choose one section to work on in the chat box and doing my corrections.
Yeah.
Is that possible that ChatGPT also changing?
No, I really don't think so. Again, if you are, what I suggest in those situations, what I personally would do in those cases is like, good that you give the Word document, because then it has the context not just of the paragraph but of everything, right? And then just ask to rephrase one particular paragraph, leave the document on the side, and then update the document with the paraphrase thing. But usually it does not change everything, okay? Because if you are specific, telling you, hey, focus there, usually it focuses there, okay? Yes?
Yeah, I mean, I was just wondering, like, whether for paraphrasing or if we're rewriting it, saying keep the content same, just increase the frequency and all that kind of thing.
So, sorry, can you
just
speak up?
The frequency of the text. The problem is, what I think is, it also changes the syntax of the text. So, I don't know, like, whether does it then fall in the gray area of generative AI?
Does it?
In the gray area of generative AI, because one of the conferences I attended recently on computational social sciences, where the scholars were really presenting that how in the past 2-3 years there has been an incremental, like there has been an increase in the use of few words, which we don't see, I mean, in earlier texts. It was both true for English and it was both for Turkish as well. So that's what, I mean, when we ask a model to, for example, paraphrase or rewrite our text, maybe the content is same, but the syntax changes, and then it also kind of, does it fall, whether it's a generative AI or not, I'm not sure, because there is a recent policy, I mean, all journals have this policy that you do not need to use generative AI.
Yeah, well, depends on the field. In computer science, it's okay if you use it for paraphrasing, because if the content is novel, then you can, have a loop with ChatGPT. What is my fear, but it is more on the, let's say, research side, is that we are losing diversity. I mean, I wrote a paper in which we developed a model in which we showed that we are losing diversity, and what I would like to do, it's like trying to validate it with some online data, okay? So what I think is that we are getting, kind of all the same, because before we were, okay, I have my style, I put the dash instead of the comma, I use the semicolon many times, there were all those signatures that were really human, and if you would have taken, 100 pieces of text written by 100 people, they looked completely different, okay? But now, all of us, we are using the same model that has been trained in the same way. It has all the, kind of signatures that he was mentioning, because some words, you wouldn't have never used them. But now, every time you read an abstract, you see some, kind of old style words that you're like, did you ask ChatGPT to write the abstract for you? I mean, I agree with that. So the whole idea of today is like, okay, let's use the tools that we have, let's use them cautiously. Yeah.
See, the other problem is if we do this paraphrasing or rewriting, even if the content is same, it will be detected by AI detectors. I've tried it like multiple times to see like.
Yeah, I mean, about detectors, I don't believe in detectors. Why? Because think of it. Think of the pace at which generative AI is evolving. I mean, if you have a subscription to any model, every 2 weeks they develop a new model, a new thing. Yesterday was 5.2, now it's 5.5. Oh my God, how quick you are. The detectors, they are built on the model of yesterday, not on the model of today. So already, what I did also, I took an abstract of an article of mine that was pre-2022. And I put it one of detector, and it was telling me it is 85% AI. And I was like, no, it didn't exist. So, Many times, okay, it can be, but there are a lot of false positives, you know. If
there is a research that says that there is problem with so there is a bias in that as well. So people from non-English backgrounds, their texts get to be detected as like flagged as AI more commonly than people from English backgrounds. So there is that problem there as well.
Okay. Yeah, but still, how do you know? You should ask everyone, what's your background? I mean, it's something that maybe you shouldn't all the time ask.
Like, I know it's not our topic, but just like in some few words, for instance, how do detectors detect? Are they, for instance, connected to the APIs of the big, for instance, GPTs like ChatGPT or Claude or something? So when a data is generated in ChatGPT, so they know it was generated there, for instance, or?
So you're asking me how do detector works? The short answer is that I don't really know. I mean, I just know one instance, but I'm sure, I mean, there is an entire community working on detectors.
I've read once they have some signs, like for instance, AI writes in a certain way. So when they
they try to see, you know, kind of watermarks. Yeah. So if you see some, as he was saying, some words that are really, you know, rare and you don't see them, I mean, people don't use that it's like a feature that tells you that's fish, maybe that's AI. But then there are much more complex architectures of which I really know little, but like sometimes you kind of try to take the text, generate it without looking at what's next, and you see how similar are, you know, your text, I mean the text that you are looking at and the one that has been generated by another model. So you kind of use a model to see, hey, did a model generate this? You can use the same model, you can even use another model, but there are many ways of doing detection. But I told you, I don't believe 100% in detectors. But yeah, that's my point of view. You can disagree, and I'm fine with that.
They also make declarations, all these AI detectors, that they're never correct. They have this declaration on the website.
I really believe that they are.
The most problematic part for using these models for paraphrasing or rewriting, they make decorative sentences. That's horrible.
They may?
Decorative sentences.
Okay.
They're empty sentences. They look good, sound good, sophisticated, but when you read them carefully, you realize that they don't really mean much. That's the problem. I try to, you know, pick out when I'm working with these models than cloud or ChatGPT.
Yeah. One of the ideas that I put on the slides is that fluency is not correctness. We could also say that fluency is not content. Yeah. That's true. Those are the risks. I mean, today it's all going to be about how can we use these tools better, and which can be the problem that may arise. So I like the discussion that we're having, because you're bringing also some new, you know, perspectives, and it's going to be kind of the entire day like that. Okay, so as I was saying, all of these tasks and many more can be done just by knowing what's coming next. Okay? You can think of your brain, right? You know what's coming next, because if you want to speak, you kind of know your next words that you're going to pick. And that's it. That's the same thing. Of course, I mean, that's not like a brain, because otherwise we would have big problems. But, you know, that's the idea. So, this block of slides, which will end with you playing around with a tool that I put on the Google Drive, it's going to be about how does the generation work. We are not going to go into the crazy details, but we are going to go at a level in which you're going to grasp how this model selects and understand what should come next. So here, well, there's a video, I don't know how to play it. This is a small program that I wrote, and you're going to do something very similar on the notebook, so you're going to have actually a better code than this, in which let's pause it 1 second, in which I mean, there you see there's a Python program. I didn't show you the code, I'm just using it as an application, and here, you know, it's doing some stuff, loading the model, blah, blah, blah. Okay, we can disregard that, okay, that's just, you know, some setup, but then you see and there is me writing, you know. I'm asking the model that's on my PC. I mean, the cool thing about this is that I have a small ChatGPT on my PC that I don't pay, and I can ask whatever I want, and I'm saying, hey, what is the capital of Italy? Okay, it says, okay, the capital of Italy, the capital city of Italy is Rome. It's a beautiful blah, blah, blah. And that's how generation works. I mean, you have a model, the model is instructed to do generation, and you can ask whatever you want. So here, what I wanted to show is that you ask the same question, you get different answers, right? I mean, I asked the exact same question, just 1.5 seconds apart. First I got, okay, it's the capital city, beautiful city, and then it's telling me about the ancient and beautiful city with a history dating back over 2000. Okay, so first thing, why do we get different results? We are going to understand that in a few slides, okay? And the other, I mean, I don't think you are as passionate as me about the fact that you have a language model on your PC to which you can ask things. Of course, it's not as powerful as the other, but the idea of doing that, it's really amazing. Also because, I can tell you, of course, from a social science perspective, that's not possible in all situations, but for computer scientists, we have a lot of computing power. We have servers and so we can download very large models, and we can have our own ChatGPT for free in the infrastructure of the university.
I tried it, and my laptop broke.
Well, we are gonna do that on Colab. Okay. Colab is cool because it provides you, and we're gonna see together, one small GPU. Okay, then we are gonna also give just 2 words of what a GPU is that you can use for free, and there you won't have the problem that your colleague experienced. Also because you have seen, I have the bulkiest laptop in the world. I was worried that they wouldn't let me take my carry-on baggage because the laptop with the power supply. See the power supply? It's like a brick. Okay, that's just for one reason, because in this thing that is very bulky and ugly, I have a GPU. Okay, so these kind of things get a little bit easier. Of course, on a consumer laptop, you can still do some things. There are small models, maybe I will show you some of them, that works even on whatever consumer laptop. But if you use a slightly bigger model, it gets frozen or you have problems. So, it just hangs there and generates one word every, few seconds, and that's the worst thing ever. But again, on Colab, we have free GPUs that we will use, and you can do something like this in which you can write task stuff and so on. And I think it's gonna be fun. Okay, so what I wanted to tell you is that, again, this is local. This is either on your personal PC or in whatever infrastructure that you're using, Colab, or if you have any other provider, it's good as well. And well, you can ask anything. Okay, so we already touched it 200 times, but I want to show you that I was prepared for those questions and those doubts, because I agree with you. Well, generation is amazing, but I don't trust it. I don't want to trust it, okay? And also, what I wrote here is that fluency is cheap, correctness not. Okay, well, fluency is not that cheap, right? It's cheap for the models because they read everything, so they are really convincing. It's like somebody that took a course for forever and they can speak perfectly. They read all the novels, whatever blogs and so on, so they speak very fluently. But, well, they are not like us. They are not correct many times. So beware of that. We are going to see some examples together. It's going to be interesting. So fluent, it's not correct, okay? The model is constructed in such a way that it gives very good text, not true text. The text just needs to seem correct. I need to convince you that I'm right, and it needs to be confident. That's what I hate. Because sometimes also myself, sometimes I write empty sentences, just to fill in, but I don't like them being so confident. If you're not sure, we are going to see a very good example in which we are going to ask a model, just, I give you some numbers, put them in increasing order. You're going to see the output of that. And those can be entirely fabricated because they have their own way of looking at things. They just tell you what they think comes next, but you have no guarantee of that being true. And this is the part in which I tell you, okay, that's bad, you cannot trust it, but there's always a but, otherwise we wouldn't be doing this session. There is a way in which you can do things better, okay? Maybe not perfect, but we will be able to do small changes to the prompt or the settings to have the output changing substantially, okay? We are gonna understand how to communicate with this machine. It's like a baby. With a baby, you cannot start talking, like a grown-up adult, right? You need to develop a specific language with which you can communicate with the baby, right? And with a model, it's kind of the same thing. You need to understand which is the right language, the right way in which you can interact with the model. So, the buzzword of today, the lecture is advanced natural language generation. When I see advanced in front of stuff, I always get scared because I'm like, oi, I don't even feel like that I'm a beginner. Why should you do some advanced stuff? But it shouldn't be really something that you have to worry about, because advanced here is like controllability, reliability, and how can you use and cast whatever tools that I'm talking you about for your research, for research use. So advanced, it's really about, okay, let's think that kind of we know how these models, how this stuff works. Let's understand how we should use them and which are the problems that may arise. Okay, so just to be on the same page, I'm sure that already we are on the same page, but just to be sure about that, there are three words that we'll be using today a lot. Some of them I already used, but I want to contextualize them and really be sure that we are all on the same page. So let's take the capital of France is Paris as an example, which, by the way, not so important, was the first thing that I ever asked to a local LLM. I asked, what is the capital of France? So, just a personal note. And we are going to talk about three terminology. Tokens, you kind of already know it, but just let's revise it. Prompt, we are going to be spending almost all day on prompt, so better be sure what it means, where it is, what is the purpose. And then autoregressive. Maybe that you don't know, okay, so that's going to be new, but we're going to see what does it mean, okay? So let's start with tokens. You all know about tokens, right? So whenever you have a piece of text, the model does not really look at words, it looks at something that resembles a word, but it's really a token, okay? So in this case, the words are the same as the tokens. So you split up in little pieces. So it's going to be one token. Capital, another one. Off, and so on and so forth. They are all tokens. Because the model does not look at the entire sequence, but it wants some small pieces, okay? The model is fed little pieces of text at a time. And before anything happens, this needs to happen, okay? So the prompt, whatever, even the output, everything is split in token, small pieces, okay? And the model sees the tokens, so the model knows, okay, you provided me capital, France, Paris, some adjectives, some verbs, and the position. That's also important, right? Because I was making an example yesterday in the beginners class in which, if you have a naive approach and you have the dog beat the man, and you don't know the position of the words, and then you have the man beat the dog, if you don't know the position, those are same sequences, but I mean, the meaning is very different, right? There are approaches that do not account for position, but of course here we are, okay, because it's pretty important. Yeah, I told you, words are not really tokens. We can think that every word is kind of a token. For example, tokenization, it's not one token, okay? Tokenization is going to be split usually in two tokens. Then it's not always the case because you have different tokenizer, but it doesn't really matter. It's just to tell you, okay, tokens are a concept that goes beyond words, okay? Also the dot, the full stop, okay? The end of a sentence, full stop, that's a token, okay? So, I mean, tokens are like any piece of text that in some sense can stay on its own, and it's not necessarily a word. Why it matters? Well,
Just a quick question. depend on the language. I don't have that much information, but there's like low resource languages, medium resource, and high resource. As far as I know, Turkish is a kind of medium resource language. So does the performance of this tokenization depends on this kind of resource level?
Probably, well, as many computer scientists, I always work with English. Even though I'm Italian, I tend to work with English. What probably will change there is that you will use another tokenizer. The tokenizer is, the tool, the function that divides the text into token. And of course, if you are using another language, you cannot use the same. Okay, because it has another vocabulary. I mean, the vocabulary that you're using impacts the tokenization, the way in which you split the words as well. Also because I imagine, and this is speculation, I'm not sure, but I know some German, and there many words are made up words, like Krankenwagen, it's like ambulance, it's like the car for the sick people. So I would imagine that a tokenizer in German would split those because there are two different things, or maybe not because together they are more, informative. So it depends on the language, but that's easy because whenever you have a problem, the documentation of all the code and libraries, tells you. Maybe sometimes maybe just, that you have an option that you say, hey, I'm working in Italian instead of English, or I'm working in Turkish instead of English. That's it. But yeah, definitely it needs to change a little bit.
This is why they say like prompting in English is better because it has more logic in terms of tokenizing what you're writing to.
Yeah, not only that's the problem of the biases. Like all this stuff, most of this stuff has been developed in English by English-speaking people or by people from the US, and so it's like all the rest, it's all the languages, Italian, Turkish, all the others are like a little bit, far away. There are also, if you think of it like, think of Wikipedia. Of course it has many languages, but for me, many times I go to Wikipedia, maybe I'm just typing in Italian because it is more natural for me for searching in Italian, and then I see the page and there are just 4 lines, I'm like, Then I go to the English page and I see 2 pages that are very well written with all the information that I needed. And so that's the fact that everything is a bit English-centric. It's not just about the tokenization. Probably there exists 1 million tokenization for English and 100 for other languages, it's just that. Everything is biased in English. The very fact that I'm speaking to you in English right now tells us that maybe it's better that you prompt in English because also the models are better at speaking English, even though they can answer in Italian, in Turkish, whatever language.
But still, the models translate, right? For example, if I prompted in Arabic, sometimes it's translated to English and give me the results in the English Wikipedia, for example, or whatever, it's just transfer, right?
In which context? What are you doing? Tell me what is the context?
I asked in Arabic. It's not just get me the information from the Arabic training.
It's telling you from it's answering in English.
Just Arabic resources, right?
Usually when you prompt in one language, usually it should answer you in the same language.
Yeah, answer in the same language, but not from just Arabic resources.
Okay, no, sure. Yeah. There's one example that we are going to see probably after the break that it shows that these models have Western biases a lot. So also on the resources, also all the media, if you write on Google, the first 3 resources are going to be, New York Times, CNN, and so on. So those type of bias are a bit tied in the training data because you have more English and Western stuff, and also in the way that information is, spread around all the, Western stuff, monopolizing the attention. So yeah, of course it may provide you also, English or let's say Western type of information. Those are biases that are there, and it's important that we know that are there, so we can try to mitigate or do something about that. Okay.
I know that tokenizers may differ from one model to another.
Yeah.
But I'm just wondering, if you happen to know a certain mechanism or criteria for this tokenization, can you just a simple.
Well, I know that they differ from one model to the other because the model is trained on the tokens that you provide. So you should always use the same language. I mean, if I decide that in my tokenizer, tokenization stays together, and I train the model in that way, then I cannot provide tokenization. I mean the split token, right? Because you have to put them together. Why do the tokenizer differ? I just think it's design choices. I mean, whomever trains and provide the model decides to use one tokenizer or the other. I'm not the number one expert in that. I don't know why one is better than the other, but at the end of the day, just a way in which you split the things. Probably those are a little bit driven by performances. Like if you see that splitting words in another way with your architecture, it's like slightly better than using another way of splitting, you tend to use the best option. Okay, so moving on in our nomenclature part, we have prompt. And well, you already know what prompt is, kind of, I'm pretty sure. And the prompt is whatever text you give the model, okay? And today we are gonna be optimizing the prompts, understanding how they works. So it's very important that you know what it is. Are all the instructions, so what you want the model to do for you, the questions, if you make some questions instead of giving an instruction, and also what we many times forget, the context. It's important that the model knows what we are doing, why, what we want, because otherwise it just relies on guessing. It's never good when somebody relies on guessing because you not really know what you're doing, right? And it's the same thing here. So this one, it's our experimental setup. I mean, it seems an overstatement, but really, writing properly the prompt, it's design. Because you cannot, well, we will, but usually you don't change the weights of the model. You don't act on the low-level details of the model. But what you can do, it's like writing the prompt properly, understanding how you should talk with the model. And so, like, for example, we have this running example of the capital of France is. Like, imagine that your prompt may be just the capital of France is, okay? And then you give this dummy prompt, okay? We are gonna write better prompts later on, to the LLM. And the LLM, we understood that when it is used as a natural language generator, it needs to predict the next token. So what's coming next? Okay, the capital of France is Paris, okay? So I will pick Paris, I will generate that. So in some sense, that's answering a question, even though what it's really doing is just predicting what comes next. Of course, this is the most fundamental part because in the prompt, you put all your assumptions, all the things that you want, the format, also your biases. We're going to see that if you bias your prompt, so there are articles that are leading towards one side and the other are on the opposite side, and you say in the prompt something that, gives away that you have one particular position, well, the model will tell you, oh, okay, you're right, all these articles are at your side. You shouldn't be biasing the model as well. We're going to see examples, so don't worry if these seem very abstract at this point. Autoregressive. What does it mean? Well, autoregressive is like a big word for saying what we have already discussed, okay? So autoregressive just means that the model generates one token at a time. This is something that I want to understand. When you see GPT, the fact that is, providing you one word at a time, it's really because it's how it works. It's one word at a time. And so each new token, it's predicted from all the previous stuff. So here you have the capital of France is, and then you predict Paris. This Paris depends on the entire sequence that comes before, but then the autoregressive part, autoregressive in the sense that you take it, you put again into yourself and you predict again. It's like you take Paris, you put it at the end of the sentence, and this becomes the new context. So you start generating from there, and then you take the LLM, and the LLM tells you, okay, full stop. I don't have to tell you anything any longer. The capital of France is Paris. And that's the final answer. Well, why is this important? Why should I introduce you this autoregressive concept that seems far-fetched? Well, it's important to understand that, because if you make some mistakes early on, then that error propagates. Because you make a mistake, you put back together into yourself, and you continue generating. So early mistakes in that generation will poison the entire sequence that comes next. So this is dangerous, because it's not like you don't have a control, you don't have a brake. It's like, driving the car, and whenever you hit the accelerator, you cannot go back. You can just accelerate more. That's very dangerous, because you can get very quick with your car, right? And here is the same. So I want you to remember what autoregressive means, because the way in which these models are designed is that, okay, you produce one token, one word at a time, then you take back into your context, and you continue producing them, okay? Any question?
I think we discussed in the winter school, but I might have forgotten it. For example, sometimes if I upload a text or I'm discussing with some idea with the model, and I said like to the model, do you think it's like this? The model says yes, it's like this. Then I change the question, but I don't think it's like this. So the model says, oh, I'm sorry, yeah, you are right again. So how do we like deal with that?
Yeah. Let's see if there's next slide. No, okay, I have another stuff. When we start prompting, the first thing that I tell you is like, never be vague. I mean, you don't have to say, hey, what do you think about that? I think that the example is exactly like, what do you think about that? Or what is your opinion on, okay? When you do something like that, it's like, it's not that good, especially if before you expose your idea. I mean, these models are also trained to make the customer happy. These are not made for, for research, for society, for advance. These are made, okay, you need to pay the $20 a month, and you need to be happy when you get an answer. So you are the smartest, the brightest person ever. Your idea is the best in the world. I mean, that's gonna be it. We need to be careful with that, okay? That's like a design thing, because it cannot say, hey, this idea is dumb. I mean, if it would tell you that, you would take the PC and throw it out of the window, right? And not paying OpenAI any longer, right? So that's important, but as I was telling you, you don't need to be vague. And also, this again, I'm skipping ahead few slides, but what's important is also not overwhelm the model with tasks. So if you have 5 ideas, discuss one idea at a time. Don't say 5 ideas and say, hey, how do you think about these ideas? I mean, it gets confused, it tells you, yeah, these are beautiful and so on. Discuss one at a time and ask, hey, I think this, and that. Maybe if you have already some, let's say, if you already identify some weaknesses and some strong points, maybe say, hey, I believe that the strong points of this approach are this, and that, but I'm not sure about this, and that, because you think that those are weaknesses. And then you spark like a kind of more reasoning and more, not think like, hey, you are the best.
Is it the same when we upload the data, for example, let's say PDFs, for example, 1 book or 2 books instead of 10 books? Is the same? Like, we'll get better results if we just give less sources?
There's also a slightly different problem. What I would suggest you, if you can, is always work with TXT files. No, that's also...
Like MD files?
MD, but they are really similar encoded MD files, either markdown files or text. Because in a PDF, sometimes, a PDF, we can read it because, okay, it's nice, but the model struggles to read it because it's not in a format in which not all the time you can just, extract the text immediately. So as a general rule of thumb, use text. If you can, have a kind of copy-paste version or whatever format that it's just, TXT. You just have text and nothing else. That's the best way of providing stuff.
It will understand better even.
It can read better. Sometimes even if you see the reasoning when you give a PDF, not always, there are some PDF that are nicely formatted and the model can read them without any problem. But sometimes when you upload some PDF and you see, there are all those thinking processes which you can see some, the reasoning part, sometimes it says, I cannot read the PDF because the format is different from what I mean, so if you have text, that's what the model likes. I mean, it's used to text. So whatever type of text you provide, that's the best thing you can do.
Then the quantity matters or not? If it is 5 different files, 10 different files, this quantity affects the qualitative results?
The answer is, it could be, again, it's like an open research problem, because, for example, Giovanni has been working on something like that. Like, for example, where the position or the density of the information affects the output, okay? What I think is that the more focused you are, the better it is. I mean, maybe even if you provide 10 documents, everything works fine, but I would give 10 documents to the model only if those are interconnected. So if you as a human would need to have the context of all those 10 documents to answer your task, I would give them. If me as human, I just need the first, I answer the first task, then the second task, and so on, I would give one at a time, okay? Of course, then in a project you can provide the files and then, just say, hey, look at this particular file, so it will focus just on that file, but that's another story. That you can do as well, okay? Okay, let's move on, still 10, 15 minutes, 10, 12 minutes, let's say. And, okay. So, I think I will tell you something and then maybe we'll play around when we come after the break. Maybe we'll do just the break 5 minutes before, and because then I want you to play around a bit and tell me what you see, because then there's going to be an interactive part. Okay, again, last time that I tell you about which token comes next. For example, we have this sentence. We have this sentence, which is the cat sat on the. What word should come next? Well, maybe we can have different options. So the cat sat on the soft. Okay, soft makes sense. Maybe it's soft armchair, soft sofa, it could be. But it could also be warm, why not? Okay, maybe the others one, okay, you have couch, you have mat, you have floor. I mean, all these kind of make sense. The models, actually, internally, they just have some options that they provide a probability to them. So, in this instance, the cat sat on the soft is that with the highest probability. So the model is really telling you, okay, I have read all the possible documents on the internet, and I know that if I'm talking with you about a cat that is sitting somewhere, he's sitting somewhere soft. Okay? So this is how it really works. We have seen that we are generating one word at a time, but we have never seen how. Well, how is like this. You have many options, soft, couch, mat, floor, and you weight them. You say, okay, it is more likely that the cat was sitting on something soft. And then you need to go on, okay, soft, well, soft rug, soft bed, already basket and light, those, do not really make sense. And indeed, they have a smaller weight. And so you choose rug. So when you choose rug, okay, the cat sat on the soft rug. Okay, nice, perfect. And then, well, then we are kind of done, right? Because the cat sat on the soft rug, the sentence can end there, or it could continue. The soft rug near something. Generation, as I was telling you, is not something that is linear. You have many options, because a sentence can continue in many different ways, right? Generating text is not that easy. You could use many words after one word. How will you decide that? Well, you have some options, and you have a way in which you can provide a probability of which one should be chosen first, okay? Okay, and then we have the cat sitting on a soft rug. It's not very beautiful, but I mean, still it seems comfy rug, right? So, do you prefer to do the break now for 10 minutes or go a little bit over time and finish early? What shall we do? I think it's better to stop now and start. Okay, so let's stop now. I will just introduce what you're going to do when we come back, because it's going to be something interactive. I want really you to try and not have a rush to get a coffee. I developed something that it's an HTML document, okay? So you just have to open it with a browser. The Google Chrome browser that you have should be fine.
It's on the file. You only put
Yeah, it's on the file. And there I made like a little dashboard in which you have, for example, in the morning, or you also have the cat set on, and then you have some, some knobs you can adjust, and then you can say, hey, choose next token, and you're gonna see what's going on, okay? So let's stop here, let's have a coffee together, and then let's play around with it, okay? Okay guys, let's start, and I want you to play now, okay? So it's play time, 10 minutes of playing. You have this file, so the file is called Autoregressive Generation Demo. I put it on the Google Drive. You should be able just, by double clicking it, it should open your default browser, and you should see something like this. Okay, I will just, say two things, and then I'll go around as usual to make it work, okay? So when and if it opens, then you have this thing in which you have the cat is on there, and what you can do is like, okay, let's choose the next token. Soft, rug, full stop. So now you know where I took the example from the slides, right? What you can do is like playing around with this thing. Now you don't know what they are, so you can just really play. Just play, and then I, of course, will introduce the concept. So play around with that and try. For example, I put sampling, and I increase the temperature, and now the cat set on the warm, light. I told you, sometimes pick sun, sometimes light. It does not make sense, but I mean, because it's a stupid model, but okay, that's part of the part of what I wanted to show you. And then it goes on, light fell across the floor. Okay, that's strange. Just play, see how crazy things you can generate. When you want to start from scratch, just do restart, and you can restart generating. So try to just generate, okay? Try to understand what's going on, and then we will discuss something together. And I will go around to whomever cannot, let's say, play around, okay?
The file is HTML.
Yeah.
Looks like
Yeah, but if you with the browser, which browser do you use?
Chrome. No, I use Safari.
has a code file that comes up. Yeah. Like this.
Okay, let's. Where is it? Well, let's download it. Okay, I go to downloads. I do like this. Where are the downloads on your PC, just to check the folder?
It worked.
Perfect. So just double click on that. I think it's okay, there.
Okay, might take time.
I take some time. It will work like that. So, well, download it first, okay? I mean, don't open it in the preview of Drive or whatever. Download it, double click it, and if you have Chrome, Safari, whatever installed, that's an HTML document, so it's gonna open like a web page, okay? It's like a web page, just local, okay? So download it first, go to the download folder, double click, and you're gonna have something like that. And then I want you to play, okay? Just play and tell me how crazy things come out, okay? What strange sentences you create, okay? I really want you to, you have those things. You have greedy and sampling that now do not mean anything. In 10 minutes you're gonna know all about that, but just, try to change those and try to change the temperature. If you don't like the fact that we are always talking about a cat, maybe I do a... If you don't like the fact that we are always talking about a cat and you are fed up with cats, you just go there, you see that there's a menu and you can select another starting sentence, okay? So play around a little bit and then we will understand what does number mean, what does gradient sampling mean, what is the temperature. That's going to be an important concept that we are going to cover today. And just try. If you have questions or if you want me to come there, just raise your hand and I will be there for you, okay? But really, try. Generate, restart, generate again, okay? When you're done generating, as I told you, you go on generating the token with chose next token. When you are fed up with that, just do restart and try a different temperature, different scheme, grading or sampling and go on with that, okay? This is not a real language model, okay, because I wanted to have it, you know, just on your browser to be quick and dirty, but just to give you the idea of what's happening. But that is how the natural language generation works. So every time you have a piece of a sentence and you need to understand, okay, what's coming next, what's coming next, what's coming next, okay? Yeah.
Even when I download it, it's still like see as a Word document.
Okay. No problem. Let's do like this. Let's do open with. Oh, you don't have a web browser? Ah, no, you have Google. Choose another app. Let's see if we can do that.
You mean in Google Chrome or something?
Yeah, I want to open it with.
Google Chrome.
Yeah. I saw that you have it there. Let me see what is the. Let's do like this. Show more options. Properties. Can I just? Yeah. We are gonna sort it out now. Ah. I didn't see the. Okay, so let's try to just do like this. It's not the best thing that we can do, but let's try to see if it works. It's open in Word, so that's not good. I want to do like this. Why it opens with Word? I don't want that. Let's try to re-download it. Can we go there? Okay. So there it is. I want it to just download it. And there, it downloaded it somewhere. And it downloads, 3 minutes ago. So now it has not been downloading yet.
It's the same thing, I think.
No, it didn't, 46, it didn't download it for some reason. You see that?
Shall I open it in command or something?
No. You know, it should be plug and play, you know.
Just reload it, maybe?
No, but it shouldn't be that the problem, you know. So let's try to, again, I want to, can I download it to a specific location? No, it downloads where it wants. What did it say? Okay, now it downloaded. Okay, and now it opens it. Okay, I don't know what happened, but you know that these things are always like that. Sure?
Just wanted to, I played around with
Yeah?
it a bit. So just trying to see like how it picks the tokens. Just wanted to ask, like, what is gradient?
Yeah,
like sampling, it says like it takes it by its probability, so like it will choose this, but then low and high, like high increases the tolerance for the next token.
Yeah, indeed.
Yeah.
I mean, I'm gonna of course explain which are the two decodings. Yeah.
Oh, okay.
I mean, I wanted to try something different because usually, you know, you tell the concepts and then you show. This time I wanted to do the opposite, like let you play and then everything is like, oh, what's that? I don't understand it, but you're already exposed to the concept and then I tell you what it means.
That's
so I'm
learning.
Yeah, I don't know that, but then you're gonna tell me and I'm gonna tell you what does it mean, but like try to just, you know, generate next token and so on, and you see that if you do greedy, it always selects the same words. If you do sampling, the phrase changes a little bit. Yeah, that's it. I mean, that's the concept that I want you to.
I just came a little bit late, so I thought maybe I missed something.
No. It's perfect. It's perfect. You are perfectly on time. Did you find some crazy sentences? Yeah.
Not a crazy sentence, but a question.
Yeah, sure.
When we compare gradient sampling,
Yeah.
What is the difference between them?
Try a restart. Try to restart there, bottom.
Reset?
Yeah. Yes. Sorry. Reset. You didn't press it. Okay. Now you just generate the tokens. Generate one sentence. No, it's okay. Sorry, it's fine. The blue one, the blue button that you see, generate next token. Yeah. Okay. Go on till the end of the sentence and look at the sentence, and then try to do sampling and look at the sentence again. So just try to do two.
When we choose greedy, it chooses the one with the highest probability.
You already know what greedy sampling is.
I got that.
The greedy.
Yeah.
See? Sorry.
For the sampling, I just didn't understand.
Okay. We will see it together.
Loyalty usually top word. I think it works like greedy somehow. But
Amazing.
but high T, the long shots get a real chance. Oh no, I didn't understand this.
What?
The high T, the long shots get a real chance.
Yeah. I will tell you now. So, well, I had this slide first, but I will first present you this slide. I'm very happy that you tried, that you played around a bit, and I'm happy to see that all of you are a little bit confused by now, also because I didn't tell you what greedy and sampling are. Well, I did it on purpose because I wanted to try to let you try and, get confused, asking yourself why, what's happening, and then telling you the thing. Because probably if I was telling you, yeah, this is greedy, this is sampling, this works like that, after maybe 2 minutes, you forgot what greedy was, what sampling was, and would never have stick with you, right? But now you're puzzled and asking, okay, what's greedy? I think that greedy always tells me sequences that are kind of the same, repetitive, whereas sampling, it has some more creativity in that, right? Well, why? I mean, the greedy decoding, these are called decoding strategies, okay? We said that these kind of natural language models are generators are decoder only, okay? So of course they need to decode somehow. When we have greedy decoding, we can still imagine that the example is this one. Then I go back to the other slide, just I want you to tell about greedy first. So the protesters gather in the square because if you were to continue that sentence, you may continue with because they, or because they, or because police. I mean, there are many words that can come after, right? We have kind of understood also with the cat example that you have kind of probabilities, okay? So I think it's more probable that after that I have they, okay? Because I want to specify something about the protesters. And what greedy strategy does, it's like, okay, I'm greedy. I want to pick the highest thing. So you just go there and you always pick the highest probability token, okay? Yeah, but I mean, it's not really creative, right? If every time I tell you something you respond in the same way, I mean, where's the discussion? Is it interesting? There are cases in which it is interesting, because imagine that you would like to do something reproducible for your research. You use a language model, right? And you want, well, if somebody else tries to redo what I'm doing, I want them to find the same results. I don't want to find them some other stuff about ancient Rome instead of the capital of Italy. I don't want that. I mean, how can I do research like that? So you may use greedy, okay? You always pick the most probable one, and the most probable is just one. It's going to be that, right? So you can use that in that situation, but there's a big problem with greedy. Greedy gives you very repetitive stuff, okay? I mean, in the example that I provided you, if you continue generating with greedy, the cats sat on the rug, the cat sat on the rug. I mean, it kept going on like that. You don't want to have, just a parrot telling you the sentence over and over again. That's useless, right? Of course, to kind of mitigate and solve this thing, there's also sampling. I mean, sampling, it's really, like in statistics, you have a bunch of stuff and you sample, you take. So you have the same distribution as you had before, but instead of always picking the first word, you also give a chance to the other, okay? So you can create sentences that are more creative, more rich, more rare. Because, you know, sometimes you just say something that you don't say all the time, right? You should pick also the rare words. And there are 1,000 different techniques to pick them. You can maybe pick just the top K and you choose among them. You can have a weight, so you pick with higher probability the they and with lower probability anger and so on. But that doesn't matter. I mean, computer scientists love to do, you know, 5,000 solutions for the same thing. But what really matters is that these are two ways of operating. This one always tells you the same thing. This one is kind of more creative. If you want reproducible stuff, usually you go with the greedy. If you want things that, you know, you are doing some type of stuff that it's like more qualitative, you would like also to extract some ideas from the text, maybe you use sampling, okay? What I usually do is I tend to use sampling because it has been proven that it provides slightly better results, okay? Because it's not constrained. Imagine, and every time you say one word preceded by other words, you always have to say the same thing. Well, that's not ideal, right? Of course, there are contexts. If you do labeling, for example, so if you have texts and you want to know whether they talk about politics, whether they talk about sports or something else, you go here. Because you don't want your label to change all the time. Because, you know, if you say that something is talking about politics, okay, you may be wrong, but you cannot say sometimes he's talking about politics, other times he's talking about sports. That's messed up, right? So, going up, okay, I wanted to wrap up also what we have seen so far, just, you know, to collect all the ideas and have them clear. So, putting everything together, generation in action. Okay, so we started with the context. We have always our prompt. Okay, so the example now is the protesters gather in the square because. That's a hanging sentence, and we won't like to go and find, you know, which may be the next tokens that continue that sentence. The first thing that a natural language generator does is understand the context. Of course, if you don't know that the protester gathered somewhere, you cannot say what's coming next. You need the context to continue, right? And that's the first part. Then, we have understood now with the example of the cat and also with what I just showed you about the coding, you have a way to say, hey, they is more probable than they. Okay? So you have your vocabulary, there are many options you can continue with, but in some way, you need to give a score to the next token. So you say, okay, it's more probable that I will say they instead of they, okay, or instead of anger. But then, when you have this thing, you need to pick something. I mean, you have to select something. We have seen that either you do greedy, so you always take the first thing, or you do sampling, so you can take one of those, okay? Let's assume that we are doing greedy. So, we pick one. We pick one token to continue. That token is going to be the next one that is being generated. And in this case, it's they. So the protesters gather in the square because they, and that would continue. Remember auto-regressive thing? You take that context, it becomes your new context, and you continue generating from there. Indeed, then you append, so now your context has become the protesters gather in the square because they, and then you repeat the same thing. That is going to be your context. You score the token that may appear next. You give weights, so this one is more probable, this one is less probable, this never appears. Okay, it can be. And then when you have that, you pick one. We have seen greedy decoding or sampling decoding. And then you continue until, of course, among those tokens, there is a special one that tells you, okay, I'm done. Otherwise, you would continue indefinitely, right? I mean, in my example, I put a hard stop, like 10 or something like that, but you would have continued to see the cat sat on the rug, the cat sat on the rug, indefinitely, okay? You don't want that. You want a way to say, okay, the sentence is good enough. Let's stop there, okay? Okay, we have already seen this. Temperature. I mentioned it, you saw it, there was like a sidebar that you could change. Well, this concept comes from physics, okay? You may know, right, that also us as human, when it's cold, we don't move too much. I mean, it's cold. We would like to keep our heat close to us. We don't want to, just wiggling around, running and so on. We stay close, right? When it's hot, when it's warmer, it's like when there's such a beautiful day in Istanbul like today and yesterday, you would like to go around, right? You are more energized, you would like to do stuff. And here, it's the same thing. Like when you have low temperature, you're more conservative with what you do. I mean, you give higher weight. You have seen that when you were moving the sidebar, okay, with the temperature, lower temperature gave you higher probabilities or of the most popular token, let's say, right? When you were increasing the temperature, you were more prone to change stuff. If you had medium temperature, well, you see here, almost surely you were going for the token 1, whereas then it was decreasing. Here, well, also token 2, it becomes attractive to use, right? And if you increase further the temperature, well, it starts to flatten out, okay? So the temperature is the same concept. If you want things to be, kind of more varied, you may mess up with the temperature. There are no golden rules, okay? So it's difficult to say, should I put 0.3 or 0.5? The answer, unfortunately, is like, yeah, you should know the temperature exists, you should try it, and you should see if it makes sense, okay? But now you know that low temperature gives you more like kind of greedy stuff. You always try to go with the highest probability thing. Whereas if you increase the temperature, well, every token has a chance to appear. Because also now, before, token 5 had a really small probability. Here, token 5 has double the probability to appear. So it's something to take into consideration, right? So this is like one of those little little parameters that you might tweak. You might see what's happening in the output.
And where will we do it?
Sorry?
Where exactly will we do it?
In the notebooks, of course.
So
There's parameters that it's called temperature, and you can put.
Local model you're talking about.
Sorry?
So it's a local model. So when you download a model.
Yeah. Now the task is really to create your assistant, okay? And so, as I was showing you before in the video, I was, asking what is the capital of Italy to a model that was on my PC. We are gonna do the same thing on Colab, okay? So now you're gonna take, 20, 30 minutes, whatever it takes. You download the first notebook that is build your own chat assistant, okay? And it's the one with one in front of it, okay? So download it, put it on Colab, and let's try to work it together, okay? The idea is that, as we were saying, now we are not gonna work with ChatGPT. We are gonna work to something that is gonna be local. It's a bit strange, but imagine that instead of having OpenAI running your model, you're running your model yourself. So you take this black box, you put it on Colab in this case, and you can ask questions and you can get answers. So we are gonna select and download the model. Of course, I already wrote the code for you, so we kind of just gonna play around and see what's happening together. And again, I told you that's a local model, and we can do some kind of messing around. Let's see now the notebook together, but I tried to kind of guide you and say, hey, let's try the model to be, more polite, or more aggressive. We can try to instruct and say different things to the model, and then it's gonna be a chat. The very last block, it's like you can ask whatever you want to. But the difference is that you don't have to pay, you have it locally, it's something that you can play around as much as you want. I found it very cool. So I'm gonna open the notebook and just gonna tell you one detail, okay? It may take some time to download the model, because we are a few of us, all will be downloading the model at the same time. So let's wait a few minutes in case. You can start reading the notebook, but the important thing that I wanted to tell you is that, wait, I have it in Italian, let's put it in English. I don't know why it does not remember your preferences. I put in English this morning because I said, hey, if I want to show them, I cannot show them in Italian. But it doesn't matter, he puts that in English and he doesn't care. So, one important thing is that you need to go up here when you are on Colab. So download the notebook, upload it on Colab. If you have problems, 30 seconds and I will be coming around. Go there and you have to change runtime type, okay? And here you're gonna have CPU selected. You want to have T4 GPU. Do you know what a GPU is? Yeah? Yeah? You So the others know it and are scared to say or don't know it? Just few words about that. So every of your PCs have a CPU, okay? It's like the big brain that makes your PC work. Fewer of them have a GPU. Mine has a GPU. Colab, fortunately, has a GPU, okay? A GPU is like just a piece of device that allows you to run language model faster, okay? Because there was this kind of advertisement from NVIDIA. They were painting something, right, at CPU mode, and they were just throwing, some paint to the wall, and in few seconds they were able to make a smiling face. And then they said, okay, let's move to the power of a GPU. They pressed a button and they painted the Mona Lisa in a split of a second, okay? If you understood that, that's enough. CPU, slow, you have it, it's cheaper, everyone has one on the PC. GPU helps you with language models. I mean, large language models, the large is really because it's something big, it's something that needs some equipment to run. So select that and then start building your own AI-powered chat assistant, okay? There's the notebook. Here I said, okay, what we want now to do is like load a small model, okay? It's gonna be the code there for you. We will go through it together. Give it a persona. What I mean by a persona? Well, when you use these models, what you can say in the prompt, it's gonna call system prompt. It's like a prompt that is always used by your model. You can say, okay, you are an helpful chat assistant that needs to answer to my questions, okay? And that's gonna be the persona of your model. Okay, so you give a first instruction saying, hey, what you should do, what I expect from you, and you do like that, okay? And then you can chat it, okay? So you can make some questions to it. So here are some details. I suggest you to keep these notebooks and, even give it a read maybe in some time just, to fix the ideas. But the cool thing about this is that I will tell you about prompting, problems, hallucination, biases, but one thing that we will do today is that we are going to have local models that everyone can run. And that's cool because, ChatGPT has some paywall, Gemini maybe less, Claude more. Here, you do it even if you have a laptop. Of course, since you may not have a GPU, it goes slower, but you have Colab. Colab, we connected to the GPU for free. They give some small GPUs for free to students, people that are learning and so on. So this one is a small model that can run on your PC, okay? So what a chat assistant actually is. Okay, I told you we are gonna build a chat assistant. It's pretty obvious what it is, right? But you need a model, okay? So what is a model? Well, we are gonna use something that is called Qwen, okay? GPT is just the name of the model. There exist many more. We will use Qwen, which is an open source model. Chinese. Sorry? Chinese one. DeepSeek, I think. I don't know if Qwen is. There are many. There is DeepSeek. There are of course all the Gemini, all the GPT, and Qwen. Then there is Gemma. There are a lot. Okay. We use Qwen because even though it is a small model, it still does something that is pretty remarkable. Okay. Then I told you the persona, and here, finally, I told you what a system prompt is. So a system prompt is at a system level. So it's not what you give to the chat. To the chat, you make your question, like, what is the capital of Italy, or what is the capital of France? Here, you kind of give an instruction of what the model always needs to do, okay? So here, you can have something like, okay, you're a careful research assistant. Be concise. You have had that experience, right? With whenever you were asking something to, I don't know, ChatGPT or so. I mean, you ask something and they provide you 2 pages of text and you never read them. You go through the things that are in bold or bullet points and so, but you have the chance to say, hey, I want a concise answer. Please don't tell me all the fact about Rome and so on and so forth. And indeed, with this be concise, you're going to see that if you ask what is the capital of France or of Italy, you should not get what I was getting. The capital of Italy is Rome, a beautiful city with 2,000 years of history and so on. You get the capital city of Italy is Rome. Concise. That's the information you want, okay? And then we are going to do an advanced part, but let's not skip ahead, okay? So, install the tools, okay? So, you have this first, yeah.
So if it's local model, so do we have to update it regularly to get latest information? Because if you remember in our winter school, we said that we were like, who won the last World Cup? It was like France, because the model was like not the latest one. But can we, if we like are prompting and doing all the hard work, then is it possible to keep updating the model so that we have the recent information in?
Well, usually you won't do that, because what you want is like you take the model, your prompt depends on the model that you're using, and that's your design. Because if you change the model with the same prompt, the answer can change drastically. I mean, models are even improving. So what you usually want to do is you select the model and you go on with that, okay? Then you can try. I mean, you will see that the model selection is really just a string. You say the name of the model. For example, now Quen, we are going to use this model, which is Quen 2.5, and then this, I'm going to tell you what it means. But, I mean, in some time there's going to be Quen 3.0, okay? Or maybe 3.1 or so on. You can change the model, probably it's better, but you know, for the sake of the research you're doing, when you use a tool, you should be using that tool again. You can try what happens with a better model, but if you, depending on what you do, you may want to stick with your model. Also, what is very important is that also the prompt is part of your design. So if you choose a prompt to get a result, you have to save that prompt. You cannot just use the prompt, get the result, put the result on the paper, and then somebody asks you, but how did you get that result? And you say, I don't remember. I mean, part of your design is the model and the prompt. Those are bounded together. So you should save them, okay? So, just, you know, do the installation. You should just, if you remember, when you have selected the GPU thing, just, you know, run that. And that installs some stuff. It shouldn't take long. The other cells probably will take longer. And okay, if I remember well, it's like 10 seconds. Let's see if we don't have problems. In any case, let's continue with the content while that's it's, you know, downloading. And you ought to choose the model. Okay, so I have been all discussing about models, large language models and those stuff, but it was not very clear so far. What kind of model? We know maybe GPT, but I mean, which are these models? Well, we have plenty of them, and as I told you, we are going to be using Quen, okay? So we are going to say that we have a small model and a large model. But I told you that these are all large language models, right? Yes, but among those, there are larger and there are smaller, right? So how do you know when a model is small or is large? Well, it's in the name, because here you have the name, and here you have the size. Those are the parameters. Many times we told you, right? Whenever you have a model, inside of it there are some parameters. You can imagine that, you know, you have tweaked them in order for the model to learn something, and the amount of parameter that you have there really tells you the size of your model. Okay? So here clearly, here we have 0.5 billions parameters, and here we have 1.5 billions parameters. So of course the second one is larger. Okay? The instruct part is just telling you some details about how it works, so you can give some instructions to make it work, but really, you can treat it just as a name. Here, I'm telling you, okay, this is pretty large, we are already talking about 1 gigabyte of model, and these are very small models. These are like toy models that we use just, to learn how everything is working. On our servers, we have like 200 billions models, but those you really can do that only if you have some high performance computing capabilities. This one though, even though are small, and we see especially this small one is like really almost a toy model, sometimes says something that makes no sense. This one, when I was preparing the slide, I thought, okay, this one is also gonna be bad. And actually at the beginning, I put another model that was bigger, but then I realized, well, it's not that bad. It's not that bad. So already this small model, it's already very interesting to explore and look at. So the installation of the stuff should have been done by now. And here, there's not much content, okay? It's just a computer science way of saying, okay, the small model has this name, has this size, and has a note, okay? Fastest. Why it's fastest? Well, it's smaller, right? I mean, since it's smaller, this one can run even on your PC. This one is so small that maybe not so quick, but you can run it on your PC. I mean, unless you have a 10-year-old PC, then maybe we'll have some troubles, but if it is like a couple of year old PC, it can work, okay? And here, you can choose the model, okay? So it's just, I want it small, I write the small, I want it large. As you know, you just do large and you throw away the small and you're working with the large one. I suggest you, since the other one is faster and we just want to play around, now it's not about how to prompt, how the bias are done and so on. Now it's just, okay, let's build our first chatbot with which we can interact on our PC. Leave it small, okay, so you can run it. It doesn't do anything. It just tells you, okay, you have selected the small model. The small model is what we have just seen and is the fastest, comfortable on both GPU, which you have, and GPU, which you have on Colab, okay? Now, this is the part that may make us cry a little bit because we are all gonna download the model at the same time. This is rather small, so we should be able to download it. So just hit the play button and tell me if it gets through, okay? Okay, so it's fast. Very good Wi-Fi connection here at the campus, so thanks to the hosting, okay? And this is the part in which you connect to the internet. I mean, why am I telling you this? Okay, these models are saved somewhere in the internet. What you can really do is like, okay, I go to the appropriate place. Here, for example, we go to Hugging Face, which is a place in which people put their models on, and we can download the weights. When we have those weights, those 0.5 billion weights, we have the model. We can run it wherever we want. I mean, I know that you're not maybe so excited about that, but this is the power of open source stuff. There are people that are doing it, and they are giving it to the community, and then you can use it. I mean, to use the model, you can do it pretty easily. To train the model, even the small ones, if you don't have some serious computing power, you won't be able to do that, okay? So, now that we have our model in place, okay, here there is a piece of code, okay, which, again, I believe that we don't have to go crazy about all the lines of code, right? Because we know that what is important are the ideas. When you have the ideas, you can say, hey, Gemini, I want to use a small language model in the Qwen family, which allows me to chat with it interactively, then it provides you the code, okay? So this code, you don't have to go crazy about it. It's important that we, let's say, know how we build it, which are the building blocks, okay? So here, this first part, this is standard. This is something that really does nothing important. It just tells you, hey, Do you have a GPU available? Well, we are on Colab, we have a GPU, so now we are gonna have a GPU, we are gonna be faster. The generation is gonna be fast. If you try the same notebook on your PC, probably will tell you, hey, I don't see any GPU, I will just work on CPU. I'm gonna be slower, but that's gonna be fine, okay? And then here are just really the building blocks that we have seen. I told you that everything starts with tokenization. So you have your words, you have to split them up somehow, okay? And then you can feed them to the model. And here, you have the model. What is the model ID? Well, we have seen before, right? The model ID is gonna be this stuff. So that's like just the name of the model. If you want to download it from the internet, you say, hey, I want that model with that name, okay? We just got it, now we can use it, okay? And so this, if we run it, I mean, just for the sake of simplicity, I wrote something that similar you're gonna see, okay? I ran it on my laptop, so what I was saying, okay, I am loading the model, okay? So what I'm doing is like I'm getting all these weights, see, loading the weights. So it's just, okay, I downloaded them, I have somewhere, and now I need to put them and use them in my program, okay? And that's it. I mean, it does it for you. You don't have to think anymore about that. We are already at the interesting part. That is just set up. The setup is standard. Even, I mean, you can get it generated from Gemini, ChatGPT, and so on that are really good at coding, or if you are a little bit more patient, or if you were, let's say, studying computer science before 2022, you just go to the documentation of the libraries. You remember Python has a lot of libraries. You go there and you read the tutorial, and they tell you what to do, okay? Because they wrote the code and they tell you exactly what to do. And so here, I'm telling you, okay, let's give our model a personality. That sounds strange, right? Because they don't have personalities, they don't really have feelings, right? But they know what you mean when you say, hey, I want you to be concise, okay? So they understand the concept of conciseness. And if you tell them, I want you to be concise, because I don't want you to tell me all about Rome, I just want to know what is the capital city of Italy, please be concise. You can tell that. You can tell them to be skeptical, okay? So these questions were posed before, like, okay, but I always get the model to tell me, yes, you are right, you are marvelous, your idea is the best one that I ever heard. You can tell them, hey, I want you to be skeptical. So I give you my ideas, but please revise them. As you were, I was saying a swear word, but as you were not a good reviewer, I mean a very good reviewer in some sense because you want them, but one that makes you really, really, change your work, okay? So you can say that. And this is like the concept of personality that you can give. But this thing you need to put in some prompt, right? So let's see. I said that sometimes you have to give a system prompt, okay? And the system prompt, it's really kind of your persona that you give to, in this case, the chat assistants. The code here, it's really gonna be, okay, I'm gonna chatting with you. What do I want? I want you to be concise. Helpful research assistance for social scientists. Why not? I mean, we are in this setting. Again, the model is small, so it's not gonna be your best research assistant, but the ideas apply to any model. Okay, you have seen that to get the model, you just have to provide a string. So there, instead of 0.5 billion, you can put 200 billion, and you have a really smart model, okay? And so here, okay, when you are unsure, say so plainly rather than guessing. This is another way of controlling it. I mean, now we are seeing them, just in an example, but then I have all a deck of slides about controllability in which we are gonna see, okay, how we should write a prompt. Because, they don't care. You have seen how do they generate, right? I mean, I'm telling you how the generator work, because they understand the context, but then they just tell you the most probable thing. If you instruct them, if in the system prompt you tell them, hey, I want you to be concise, helpful, and if you don't know what to say, tell me that you don't know, okay? Of course, you're asking a machine something that is more related to a human. So sometimes it breaks, not all the time it makes sense, but you're giving a direction. Before, there was no direction. Now you're saying, please, try to do so, okay? And it works. We are going to see examples in which it really changes what you get as an output. Okay, so we are going to see one last function together, high level, and then you need to play around yourself a little bit. The code is already written, so no, coding stuff that you need to do, but I want you to play with the system prompt. So you can ask to be mean, you can ask to, I don't know, not be concise, but be, very respond with as much text as it can. Just play around with it and see how the answers change. And to do that, of course, we have the weights, we have the model. You need to have a function, okay, that allows you to ask stuff, right? Ideally, you would want to have. I want to ask you something, okay? And here, I wrote a function for you. It's generate reply. You see that there are some parameters. For example, do you see here? You have temperature. Try to change the temperature, okay? So do what we have done, and there, instead of putting 0.6, put 0 or 0.5 or 2, okay? Play around a bit. I mean, the code is there. It should be working. Let's see, then you're gonna tell me. And so this one, really, what it does is, okay, it formats the conversation. We always said the data needs to be understood by the model. So this is a passage that it's really standard, and it just, tokenizes the input, divides it as we have seen, takes the context, and so on, okay? You can do this streaming thing, but it's not very important. Just, forget about that. But then you put your settings, okay? For example, here, you specify the temperature. That's pretty important. We have seen the temperature change what you get. And so that is the model. Okay, here you see generate reply is ready. We are done. Now we have the function that allows us to, interact with the model. So now what we shall do? We can say like this, okay? We have some messages, okay? The first one is, okay, the role system. I have been telling you that there are many times is a system prompt. A system prompt is specific. You see here you are a system, here you are a user. The way in which the models are trained, developed, made them understand whether it's like something that you say at the system level, so high level instruction that I want to give you, and low level instruction that I want to give you. So the question that the user is going to make you. So the system is going to be what we write before. Remember, you're a helpful assistant that responds concisely, and when he's unsure about something, says that plainly. Okay? And now we are, okay, in one sentence, what is a language model? It's not that easy of a question. And also, I find it rather funny to, ask a language model to tell you what is a language model, right? It's kind of a self-consuming loop, right? But let's try. Here we just say, okay, our reply is gonna be generate reply. We know the functions, right? You didn't remember the basics we learned together in February. Okay, so a function is something that, okay, you provide the input, your messages, and it provides you the output, in this case the reply. Okay, so now, just let's see if it works. Okay, so it's the assist, it's generating, you see? This has been generating in real time now, locally hosted on Colab. We are not paying anything. We are not giving money to anyone, okay? So we can even see the result. Here it's like a language model is an artificial intelligence system designed to generate human-like text based on input provided by a user or a program. Well, it's not that bad. It's not that bad. Now I want you to act here, okay? Try to change that part and ask anything. Just play around. Then what I want you to do is try to change the system prompt. Go here. Let's see where there are those triangles. It's like where you could play around and say, hey, you are a very mean assistant, and see what happens, okay? So just play around, and then I want some of you telling me what they see, okay? Let's try it. Just, you have two places in which you have to look at, so change the question, and the question is here, there the question, and then the system prompt. And the beauty of it is that that's really your assistant. You are not paying, you are on free resources, and you developed your model. I mean, you have a model that's answering you, okay? I think I find it kind of cool, you know, by now, but yeah, just try it and let's discuss if you want to discuss about something. Yeah, sure.
It says when I'm trying to chat with you that the system prompt is not working.
Okay.
Maybe I added stuff
Yeah,
to it.
no.
Maybe it's like
go,
extra.
try to go up.
This is like, it's pretty long.
Try run it.
Running it?
Yeah.
Oh, I didn't run it before.
Okay, now you're done.
Oh,
now it should work.
okay,
Try to go down,
Let's see.
and then it should be working. Try to. It should be
Is
there.
there here? Where's the cat?
Yeah.
Okay, let's see.
Okay, now
thank
it
you.
works.
Thanks,
No
Emma.
problem.
Specializing in personality disorders. This is just like completely without Let's change it as a system prompt.
Ah.
In one sample, I don't know.
Now he's working the chat thing.
I'm just checking out because it was loading.
Ah, okay. Yeah, on the PC it might get stuck, but I mean there.
Here, what I did is like I installed Olama. You know,
Okay.
there's this gamma.
Yeah.
From
Gemma, yeah, I used it as well.
I don't know, when I just clicked hello, it just froze.
It froze.
Yeah.
Oh, I don't know. You know, usually I downloaded Llama as well, but I'm using with Python. There is a library called Ollama, OLL Llama, and then you can use Llama through, let's say, directly the Python interface.
Yeah, I see, but because you know this is an easier interface.
Yeah, I know that, but I have no, familiarity with that, so I won't be able to help you. But this code that I provided you, I think you can even try on your PC.
Like in the terminal, you mean?
You have a Python installed or something?
No,
I think the best thing to do really, because the T4 GPU that Collab is providing, it's good. It's better than mine. The one that of my bulky PC that I hate to carry around, it's worse than the one that Collab provides you for free. So when you want to play around with that, I think you can use that. And I mean, can you just go on the notebook? The interface is not that good, this one, but look here. I mean, we are gonna go on to get. Oh, sorry. Is it my notebook?
Yeah, it is.
This is YouTube, I think.
Oh, okay. So
somewhere else.
should you do this one?
Yeah. Here in the last part, I put it as optional, but I will tell you. We will go through it together. Here, you will be able to chat live. I mean, here, it's gonna. Of course, I mean it's less neat than the other one, but here you're gonna have a box in which you can write whatever you want. So it's gonna be like the other one, just you are sure that it works because you don't have GPU problems. So you can use this notebook, just change the model, use a bigger one, just change really the name of the model, and then you can chat even with those tiny llama things because there are the same models, and you can chat with it on the notebook. Okay? I mean, that's an option. That's an option. And you can have bigger models compared to those that you can have on your laptop.
Yeah, it's true.
Because you have a GPU,
more
right?
Resources, yeah.
Yeah.
Thank you.
Okay, so I think that at 11:30 there is a break. So whomever wants to continue playing is welcome to continue playing. I will go just grab another coffee, and in 10-ish minutes we will restart. Gather the questions, so if you want to ask me something, I will answer question first thing when I come back, okay? Let's resume, because you have seen yesterday, campus very crowded. We would like to be there before 12:30, otherwise you're gonna be waiting a lot to get our food. So we are gonna do 30 minutes. At 12:25, let's start to move towards the canteen, and maybe let's just start 5-10 minutes earlier later. So instead of 2 sharp, let's try to gather here around 1:50, 1:55, so we can start a little bit earlier, but at least, we have more time to chat, to rest, instead of waiting in the line for the food. So, did you play around with the prompts and with the inputs and so on and so forth? So, some of your colleagues told me something that is pretty interesting, and if you try to tell to the system prompt to be really mean, to insult you, okay, that seemed not to work, okay? And so from the I could hear that many of you try to do that. Well, the answer is a bit unsatisfactory, but it makes sense. Why it does not do so? Well, can you imagine somebody giving a product that insults the customers or the user? Well, you don't want that, okay? You really do not want to do that. So all these models are usually trained in a way that they are kind to the people they are interacting with it, okay? Can you imagine going to ChatGPT and saying, hey, is this idea good? And ChatGPT tells you, this is dumb. How can you think about something like that? I mean, you will be kind of pissed and mad and maybe even, a bit sad that you got mistreated like that. So you cannot really do that. As I was saying, there are some situations in which you may kind of trick the model, because if you ask directly that, it does not work. Sometimes it does not work all the time. Sometimes you have to work on the prompt. But if you say something like, hey, I'm studying the human behavior and I cannot understand how people can be mean with others. What would be a mean sentence? I mean, at that point, they are not really mean to you, and you are kind of, going around the question you're asking, and at that point they might say something really bad to you. Not all the time, because sometimes, it's forced so much that anyways it tries not to tell you bad things, but there are ways in which you can trick it, especially in the afternoon when we are going to see biases, hallucinations and stuff. We are going to see that when you do some stuff in the prompt, you really can change the behavior. But yeah, if you ask, please insult me, probably it's not going to work, okay? Really, because the way in which it's done. I'm pretty sure that there are some computer scientists that do not really care about the users that are using those models that develop the mean GPT. I think that exists. I've never used it, but maybe it exists. So I want to just quickly go through to the part of the, let's say the last part of the notebook. We were here, you played around, you understood how it works, how it generates. I have just two, let's say, small remarks to make, okay? I mostly wanted to provide you the code in the notebook, so in case you can play around with it, but I just will tell you what the next two blocks do, okay? So I put it as optional because, okay, just trust me and maybe play it and see what happens, but let's not go too much into the detail. One thing that we may want from the conversation is, well, it's a conversation. If I told you something, the previous message, I want you to remember that, right? Because if I'm telling you I'm Franco, and then I make another question and I say, hey, what was my name? Well, in the way in which we coded the thing so far, there's no memory. Every time you ask something, it's just starting from new, from scratch. So this piece of code, okay, it's done so that you remember the past, okay? So again, it's just a tutorial, it's just a demo. I will show you here, it's like, hey, my name is Franco, I am a computer science researcher. Okay, so I tell the model this, okay, and the model, hello Franco, it's nice to meet you, how can I assist you with your work? Now, if we were with the code of before, you wouldn't get memory. So if I would ask, hey, what my name was, it wouldn't have that information. Here, we are kind of saving that information and giving back to the model. And indeed, if I say this, let's hope that it works, remind me, what did I say my name was? Hey, your name was Franco. So this is a way of keeping memory. Again, if you really want a chat bot, you would like to have your answer saved as well, and that's how ChatGPT works, remember? I mean, if you have a question and after two other questions, you have a follow-up question of the previous question, well, it has memory, it remembers what you have said. Really simple. The last part, I think, is the cool part. And again, let's forget about the code, okay? The code I provided it for you. We run this part, and here you see that you have a box. So let's try to do something together. Like, what is the capital of Italy? Okay. The capital of Italy is Rome. Really fast in answering. I have another question. I don't know. Ask me something that I can prompt to the model. What are you curious about? Nothing? What is the best dish in Turkey? The best dish is in this falafel.
No, really.
And we are going to see these type of things also later. I told you that there are a lot of biases, a lot of, outputs that do not make any sense. And this is one of those. Why? We are using a very small model that has not access to internet. If I do something different, what is the best dish in Italy? You see, I love that. I love what he said. And I mean, I didn't want to show you this type of thing already, but I have some slides on that. These models are Western-centric, are Eurocentric and more America-centric, okay? We are going to see in the example that I actually wanted to show you later. I mean, why don't they know about Turkey? And they told me 5 things about Italy. I mean, pizza, yeah. Pasta, yeah. Risotto, yes. Gelato, even tiramisu. Come on, really? These are all the biases that are in these models, okay? Yes?
I asked how do elephants jump?
How do?
Elephants jump.
Okay.
And then it explains how elephants can jump. So there might be some sort of, I don't know how to, because I asked something wrong and then it explained how this wrong thing happens.
Yeah. I mean, that's called hallucination, right? I mean, the model does not really understand. Also, those of you that were with me in the beginner session, I remember there was a slide in which I put some kittens, and the question at the top of the slide was, can this machine really be intelligent? And I told you, no, not in the way that we think of. They see patterns. So there, the pattern is like, okay, you are asking me about jump. Okay, I don't care about elephant, I'm just telling you about jump. Why not? I mean, it's more probable that maybe you just put elephant, but you were thinking of something else, right? So those are the problems with these models. And I mean, this afternoon it's going to be all about that. As I told you, one of the examples is like, hey, you have these numbers. It is like 2, 20, 4, and 7. Put them in order. You're going to see what's the output going to be. Crazy, okay? And this is, it's more a class about awareness and how to avoid these things. First, you need to know that some crazy thing happened. And then you need to know how to mitigate those. Of course, here, remember, we are using one of the smallest model possible. So it's kind of the dumbest model possible. So really, you can trick it easily. But those things can happen also with larger things, okay? So definitely, you ask how an elephant jump, it tells you what that. In the slides, I have an example in which sometimes if you ask a model, what is in this picture? And you didn't show any picture, it tells you there's a golden retriever there. I didn't provide you any picture. Why there's a golden retriever there? I mean, these are the problems. And now I think you can, you start getting, a feeling on why this happens. Like, yeah, it's just, predicting the next token, the next word. It's not really, I mean, it's kind of understanding the context, but not like we understand the context, okay? Okay, so, I mean, there you can do quit, and it's gonna stop, okay? But, I mean, I thought, and now you know that I was really excited of this, that you have your dumb assistant there and you can interact for free as much as you want there. So, it was just you as a trial, a proof of concept to do together. Now, okay, here, again, we have already done that. You can do more. But now, I would like to go to some slides, okay? let's try to speak a little bit about controlling generation. And again, we have 20-ish minutes, a little bit less, so we are going to start it and we are going to resume after lunch. So, I told you 100 times already, you are bored of me saying that, but really, prompting is design. So the prompt is not just something that you put there and you say, okay, whatever, the model understands that, I can be sloppy as much as I want. It's not really true. That's really part of your design, because you're not gonna train a large language model from scratch. You're gonna use the model of somebody else. You need to understand which model you shall use and how to use it, and we are gonna learn it together. So this is some code that you may use, okay, and what we shall look at is like, okay, I have a prompt that is, what do people think about the policy? Okay, that's something that you may ask to, your student, your colleague, that is very general. Then you can, add something, specify it, but this is really vague. I mean, I'm not providing you any context. I'm not telling you what I expect you to say. I'm not telling you what are we talking about. That's the worst thing that you can do. Because the model is just going to say something about, like the elephant. Okay, the elephant can jump in this and that way, okay. So, the prompt, many times, it's like just written once. You don't really optimize the prompt. I mean, this thing, usually when you do a design of a research project, you get your first idea, then you talk with colleagues, you read literature, and then you revise your idea. And then, again, you start doing some preliminary analysis, and you go back to your question and say, does it make sense? Does it not make sense? I'm going to the right direction, and so on. Okay, why you don't do that with a prompt? You just ask it and then you say, the model does not understand anything. No, you should do the same thing. You should revise it. Okay, if it is not satisfactory, if it does not work, if you don't get what you want to get, you need to go back and write something better. I mean, here is your experimental design. We have done the chatbot, and I told you, hey, forget about the code. I mean, those were just, most of it, call to function that somebody else wrote. Any, let's say, coding assistant can help you writing those. There is where you need to act. We need to know how to write properly prompts and what can go wrong. So there are, as we discussed, other things that you may touch, may change in order to have different results. Remember the temperature? I mean, for example, the temperature, you can get it bigger, smaller, you can play around with it, see how varied the results that you get are. If you want something that is deterministic, then you may want to set the temperature to 0, so you always get the same result. So also that, it's like a design choice that you have to make. And most importantly, your prompt holds your assumptions, your tasks, whatever that you're doing. Remember also, assumptions are not, shouldn't be biases, okay? If you have one idea, you should, do one step behind and try to ask really the question, not what you already think about that, okay? Because you can inject biases in the prompt as well. You can have a stance on whatever you're doing. I mean, we need to have a stance. We cannot just, say that we are neutral to everything. But when you do the design, you should be neutral and see what the model tells you. This, many times by everyone, this step is skipped. You just, do this for me. I don't want to think too much about it. You know everything, so do it for me. I don't think about what I should tell you. But this, it's very, very, very important. Never done in a single step. It's an iterative process, and you have to refine it and know how to write it. So, for example, let's see some example of what I mean of how we should be writing a prompt. So we have a task that is like summarization. We have said that summarization may be one of the tasks that you can do with natural language generation. And you have some public reactions to a new policy. I mean, this example is also in the notebook. It's very simple. I mean, I made up some let's say, point of view about a policy, but we are gonna see that in practice as well. So let's analyze this task with 3 prompts. So the first one, vague, I told you. when you're not really specific, you are kind of letting the model do the job, but then you are not really getting what you want or what you need. You're just getting what the model is generating. So what do people think about the new policy? I mean, it does not seem so bad, but when you see the structure one, it's way better. I mean, it's not rocket science. I mean, here you say, hey, from the text below, so that means that I'm actually providing you the sentences in which the people are telling what they think about the policy. From the text below, list 3 most common concerns with a supporting quote. Then you are instructing, hey, read the text. So here, what do people think about the new policy? It may just tell you generally, okay, new policies usually have some people that are in favor and some people that are against. Yes, but I don't care about general stuff. I want something that is related to what I'm doing. So you say, hey, I provide you the text, read it below, and please tell me the 3 most common concerns. But then you go a step further and you say, hey, I also want a supporting quote. So take the text that you have been, that has been important for your decision of telling me, okay, these are the most common concerns, and put it to my output. So you can check it. Oh, is this sentence there? Yes, the sentence is there. Okay, that makes sense. Okay, I agree that that's a concern. Then is also the problem in biasing. So if you put some bias in the prompt, like explain why people oppose the new policy. Well, the model usually tends to tell you all the opposite point of views that there are in your text, but maybe it neglects those that are in favor. I mean, you don't want that. Usually you want to know what's the truth behind, what's really going on. So you don't want something biased, you want something structured. So we are going to learn which are some ingredients that we may use to do this kind of structured prompting. So again, this is just repetition. Your prompt is indeed part of your experimental design. You need to go over it. You need to understand what you should ask, what you really want, and also your thesis, what you are trying to prove or see. Try to not put it to the prompt already. Otherwise, it's like saying, tell me why people don't like it. Maybe there are 5 people that are liking the policy and 1 that does not like it. Maybe the model says, hey, okay, it's asking me about not liking the policy, so I will say, hey, I don't like it because so and so, and report just the minority point of view. That's not good, and maybe you don't realize, right? Because if you have 5 policy opinions, okay, you can go through them. If you try to scale, we always try to scale to thousands. I mean, you don't know if you don't design properly your prompt, maybe you get those biases, and then your statement, your claim at the end is completely wrong. It's dangerous. If you don't know it, it's dangerous. Let's do like this. Let's open the notebook. Let's go through it a little bit together, but we have 10 minutes. So we are just gonna, get acquainted with what I'm meaning with these things and just, do the setup. And then we are going to go to lunch, okay? So, one thing to remember, when you are using GPUs, you can have just one session running, okay? So you need to close the previous notebook and open the new one. It's the one flag with the 2. So this one, 2, prompting and failures. Let's do the same that we have just did. So upload to Colab, select the GPU, and let's see it together, okay? If you have problem, raise your hands. I'm here to help you. So, I need to do the same, so. Sorry?
Are we going to select CPU or T4 CPU?
T4 GPU. Yeah. Anytime I told you, the technical difference is not that important. Maybe I'll try to find during the lunch break that video that I was mentioning. That will stick to your mind. CPU is something that is what makes the laptop and desktop PC run, but it's kind of sequential, is slow. the GPU does 1,000 times 1,000 things in parallel, okay? So it's something that really helps you doing very quickly, okay? So the GPU, it's like, okay, I put my model there and it's gonna generate token fast. I mean, what you need to know is just that. And Colab give us for free a GPU, so let's just use it, right? Okay, so let's just to try to get the ideas of the things that probably we are gonna see together after lunch, okay? So again, here we are gonna use, again, our Quen model. Now, we are gonna try to see the effect of the model size on what we are doing. So I told you, right, that this 0.5b, 1.5b, it's like the size of the model, how many parameters you are using. And here we are gonna use a small model, a medium model, and a larger model. It's gonna change something? Well, we don't know, let's see. We are gonna try it together, okay? And this, it's gonna be the setup, okay? I mean, all the steps that we're gonna do together. So first of all, there are always gonna be, okay, initialization, all the function that we need, all that stuff, that it's not that important because, I mean, you need it to be doing what we do, but it's really standard. It just, you know, you can think it of a wrapper around the model just to be able to talk to the model, and that's it, okay? And then it starts the cool things, okay? What I kind of like. So here you have what we have just seen in the slides. You have a vague prompt, then you try to do a structured one, and then a biased one. Well, remember that these things do not always work. Sometimes you really get what I'm saying, okay, exactly. Sometimes you get slightly different things, like in the example of, hey, please be very mean with me. Then we can discuss, hey, why it does not work. And also, as I was saying about the detector discussion, right? These models evolve really fast. If something does not work well, they patch it and they make it better in order to work best, okay? So, you know, all the models, even though they are small, when I started working with these things with very small models 4 years ago, oh my gosh, the small models were not working. They were really telling you things that, I mean, made no sense. But now, they are pretty good already, okay? And then, I think we are gonna see the slides first. Here, I told you already, I would like to see with you the anatomy of a prompt, okay? So, which should be all the characteristics, all the things that you should put in a prompt to have it structured and effective. And I think that slides are gonna be helpful because whenever you're gonna write a prompt, you're gonna think of me and you're gonna say, hey, no, I cannot just ask, what do you think about that? I'm gonna need to be structured and really ask the proper things, okay? Then it's gonna be, as I told you, small models versus large models. Does it change something? What are the outputs? It may be interesting, right? Because small models, we said, are fast, can be run on smaller laptops, and you don't need so much computational power, but are they good enough? Let's see. And here is the part that I like, and here, I mean, I put just 3 examples, but I know that you are, you are very creative, so when we get there, I want you to try to find other examples of those problems, and maybe we collect those and we discuss those together, okay? Like the one of what is the best dish in Turkey? I mean, I found it by chance with you, okay? I didn't think about that. I thought it was good enough to tell me something that was meaningful. And we saw that there is a huge bias in the European part and Western part in which, okay, about Italy they know everything. That's not fair. Why? Okay, and so this part is gonna be, okay, provoke an hallucination. We already see one, the jumping elephant. Provoke a bias. We have the one of, okay, about Italy they know everything, but about Turkey they know little. And provoke overconfidence. I told you, one of the problems is that they are not unsure about the answer. They tell you things that, I mean, they seem to be very sure about what they are telling you. And we are gonna see the example that I already told you about the order in sequence, and they are gonna mess up, okay? So, I think the best thing now is to stop, and we resume but 10 minutes earlier. So instead of 1:50, as I told you, come here at 1:45. So we are gonna go there just not to, get stuck in the queue, and let's start a little bit earlier, okay? Are you all good with this? It's fine. I think
120 or 140?
145, yeah. Okay, thanks, and we are gonna do some hands-on stuff later on, okay? Thank you so much. Okay, there. So we shall start, okay? We left with an open notebook, and we needed to start looking into that. So I maybe didn't organize it in the best way, but we are gonna do some cells together, discuss it, see the result and so on, then go back to the slides, see some of the theory, okay, and then go back to the notebook. So I'll tell you something, we try it, we go back, and I tell you something else, and then we try it again, okay? We are gonna do that loop. So we were with our notebook, okay, and we discussed a little bit what we are gonna do. Now we are gonna deal with a slightly bigger model, so it's gonna take some more time to download. So what I suggest you to do now is please run all the cells, so the first one, the second one, the third one, and then this one. You'll see that I'm already running those, because this one takes some time. You see, here, we didn't see it earlier because we were downloading a small model. I told you, this is a really small model, it may be dumb a little bit, and we are gonna be working with a slightly larger model later. Here, we are downloading a much bigger model, but you see that it takes some time. And since all of us, we are downloading it at the same time, it's gonna take some more time. So just run the first 5 cells, and in the meanwhile, I'm telling you what we are gonna do, okay? So, first thing first, okay, you are running the first cells 1, 2, 3, 4, 5 in the background. In the meanwhile, I'll tell you stuff, okay? So here again, it's the part of setup, okay, that I did it for you. And again, if you use Gemini, Gemini will do it for you, so you don't have to worry too much. It's just saying, okay, here, remember, I'm taking all the libraries, all the code that somebody else wrote, and I'm gonna put inside my program, right? Here I'm managing the CPU and GPU thing. You see that here I'm seeing that, okay, I have a Tesla T4. So we are on Collab. Remember always to go there, change the runtime type, and go to T4 GPU. We need that. I mean, especially for this notebook, we need that. And then, as we did before, remember that I was defining a function with which we could ask things to the model, okay? So similarly, I did a function that does like that. So first of all, we load the model. Loading the model means we download it, okay? We need to take it and put inside our program to make it work. And then we have chat that, of course, as you can imagine, you just provide some information, you provide the model that you would like to use, the temperature if you would like, and then this stuff, okay, it's needed just to, take all your context, all your sentence, whatever you are asking, and giving it to the model in order to generate, okay? This is a super standard function, okay? So of course, all the details seem a bit fuzzy and it's not so clear, but if you ask Gemini, hey, please, I would like to have a function that allows me to give some prompts to a model, it's gonna give you something really like it. Or you can reuse this code. This code is there for you to use. So, well, while I was speaking, at least mine says warm up done. So I downloaded the model, everything was fine, and maybe you need some more time, but I still want to tell you something. We have seen a slide in which we had 3 types of prompts, right? One that was not really well specified, one that was structured, and one that was biased, okay? So now what we are gonna do is okay, I took some kind of very simple sentences, okay, which are, for example, finally some support for families. I did some mess. Okay, now it's okay. Finally, some support for families, long overdue. So they are talking about some policy, as was the example in the slide, and we kind of want to know with the model, with the language model, if it can extract the, let's say, the leaning of the people talking about the policy. So this is kind of a standard thing that you may want to do. So we have responses, so you have ideas of people, somebody write a comment or they write somewhere, or you were interacting with them and you just write it down what they were saying. And here you see we have our prompts. Prompts is just text. I mean, I like this lecture because I'm telling you things that apart from the wrapping code that I wrote it for you, what you need to do, it's kind of simple because you need to write. Probably you write prompts that are much better than mine once you know which the structure should be. So let's start with the vague prompt. Okay, what do people think about the new policy? Okay, it was the vague prompt, a little bit unstructured. Let's see what it gives us. Then we have the structured one that is very similar to the one that we have seen. Okay, from the response below, list 3 of the most common concerns. So we are already giving a structure of what we expect in return. I don't want to know everything, okay? I just want to know the main bullets, the things that are recurring in my responses. I would like to focus on some summary. Otherwise I go through all the responses, no? And then I have the biased one. That's the most dangerous one because you may or you may not induce the model in telling you something that it's like already embedded in the prompt. So here you say, explain why people oppose to the new policy. So you are kind of saying, hey, people are against that, tell me why. But I mean, the responses could be either way, so you shouldn't be putting the bias into your prompt. So again, here it's in some of these notebooks, there's going to be illustrative output that it's not really a true output, but it's what can happen. So I just put it there for, you know, that is what can happen. And of course, together we can see what actually happens. So let's run the cell together. It takes some more time. Why? Because I told you now we are experimenting with a slightly larger models. And when the model is a little bit larger, it requires more resources and it also takes more time to respond. Okay, now we got our response. So, in the vague, when we were saying, hey, tell me what they think about the policies. Okay, people's opinions on new policies can vary widely. Why you are telling me that? I told you, I mean, there are some responses. Why are you giving me general stuff? If you are vague, when you ask things, the model gonna be vague as well. It says things that are always true. People's opinions on new policies can vary widely depending on the specific circumstances and how they perceive the benefits and challenges associated with them. That is what you were saying me. There's no content there. They are just, it's an empty sentence, right? Because you are not telling what you want and exactly directing the model in telling what you need. And then what it does, it's like sentence by sentence, it kind of rephrases the sentence. I mean, this is longer than what we provided. I mean, we had these 5 sentences. I mean, I prefer to read those sentences than this like very long response, right? Are we gonna get something that is better with the structured prompt? Well, the model is the same. Remember, we have Quen 2.5. We are just asking something differently. Let's see what happens. Okay, here are 3 most common concerns along with their labels. So what the model think is like a summary of it, okay? And verbatim quotes, because in the prompt we are asking, okay, for each of the most common concerns, please provide a label, which needs to be short, so I can really know, okay, this is talking about this, the concern is that, okay, without, you know, just generating text without a scope and a name. And then I want a quote. Why do I want a quote? Because I want it to verify. I mean, okay, you are telling me that those are the most things that are most important, but I want you to know where did you find that information? So I can go in my corpus, maybe it's like 1,000 pages, but I have the citation. So I can just do Control F, I search in the page, and I see, is it there? So, you know, the model now needs to give me some evidence about what it's saying. So let's see. Same model, same everything, just prompt changing. Okay. Rollout chaos. Okay. The idea is fine, but rolling it out in 3 months is chaos. That was one of the sentences. So rollout chaos makes sense. This is one of the opinions that were discussed there. Then we have lack of inclusion. No one asked small businesses. Okay, that makes sense. I mean, nobody thought about businesses. It was related to the fact that the policy is not really inclusive. And then we have complexity and uncertainty, okay? So I don't really understand what changes for me are day to day, okay? So here you see that you use the same model, same setting, same functions, but just giving clear instruction, you got completely different answers. I mean, this I hope that you understand that it's very important how you prompt. So how you ask things, you need to have crystal clear in your mind what you want to have in return, and you're gonna get it. If you are sloppy in doing that, the answer is gonna be sloppy as well, and you don't get much information from it. Again, the biased one starts from the fact that the people opposed to a new policy. So here it's people opposition to a new policy can stem from various factors. Again, it's vague. It's not on point, it's not on the stuff that you provided. Why? Because you were just talking about the opposition and you were not being careful in how you specified your request. Okay? Are you there with me? Is it the example convincing?
Can I ask something?
Sure.
That various, can we assume that various includes every variety, or there will be any pre-selection that the model can come up with?
About the factors, you mean?
Yes.
There, I mean, I showed you, right, how they generate the next word, right? So there, there's gonna be a bias according to how the model is trained. So probably it's not so big, the spectrum. Probably it's gonna be a bit narrow based on what the model has seen previously. But we are going to see some techniques in which you can provide the context. It's like when you were uploading your document to ChatGPT, you were giving the context. So ChatGPT or also these type of models are able to read, and then they can look for information there. Okay, otherwise they just have to rely to whatever they have seen in the past. But it's not that effective, right? Okay, so again, here is a summary with what we have seen. I mean, I think I convinced you. I just took the same things that I put on the slide. We have tried with the model, and indeed, we are seeing the behavior I promised you we would have seen. Now the question is, what shall we do? So, I'm a bit ahead. We were here. Okay. Little slide, and I'm gonna tell you about the anatomy of the prompt. I told you that this slide was coming, right? So now we are gonna try to understand what we should put in a prompt to make it effective. But not only that, maybe we have seen already from the notebook, we have the next cell is indeed anatomy of a prompt. So we are gonna start with a very simple prompt, then we are going to add the number one ingredient that I'm going to tell you, then the second one, the third one, and we are going to see the improvements in the response that we get using the same model. So it's like using the same tool. I mean, think of a hammer, right? The hammer has two ends, and you usually, when you want to hammer a nail in the table, you use the right end, right? If you're hammering the nail with the other part, or with the with the wooden part, I mean, the nail does not get into the wood, right? Here is the same thing. You can use this. You can use the model, but if you use it wrongly because you don't know how to instruct it, then you're never gonna get decent results. So, first thing, role, persona. it's like a high-level task. We already did that when we were setting the system prompt. The system prompt for our chat-based interactive LLM was like, hey, you are a helpful assistant and you should be concise, for example. So you are saying, okay, how should you act? This is also in the direction of some question that you have made. It's like, do you want something that is really concise? Do I want something that is more, textual, and you try to explain things? You may steer the model in that direction. If you want a paragraph to be written, you should say, hey, I want you to respond with a paragraph to the question that I'm asking you. If you want one word, you should say, hey, I want one word. I don't want an entire paragraph. But if you don't say that, how can the model know which type of output do you want? So, for example, again, we can say, hey, you are a research analysis summarizing qualitative feedback. So you have your qualitative feedback, and first of all, you're specifying that, okay, you are going to be exposed to qualitative feedback. I want you to be a research analyst that is going to be summarizing those. You are steering, right? Instead of saying, hey, summarize this, without context, if you give it to anyone, you go out on the street and you say, hey, summarize this. It's difficult. I mean, you should talk with somebody that has some experience at least, can read the jargon. Task. We also had a discussion during the break. My take is that the more specific you are, the better it is. I mean, if you are interacting with a very big model, very powerful model, you can give 5 tasks at a time and it's fine. So you can say, hey, I want to paraphrase this paragraph, but also I want you to extend it by adding a table in which you retrieve the data from the internet. I mean, slowly. Why you should overwhelm the model? You can do that because sometimes big models are good at doing it, but it's better that you structure what you need to do. So the task, okay, try to have a single operation. So if you have things that are related, okay, maybe you have to do them together. But if you can separate them and doing, okay, step 1, and then the output of step 1, I look at it, I validate it, and I do step 2. And I go on, so on and so forth. The model really knows where to focus. If you give, I mean, imagine to one of your colleagues, you are co-workers, and you are having a meeting and you are splitting the various tasks, but you are not at the desk, you are just talking about that at the cafeteria, and you say, okay, you need to do this, 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 and that. You say 5 things. The person does not have a pen or does not write down things. Well, probably will come back with just 2 of them done because the other one has been forgotten, right? Something very similar happens here as well. So try to be specific. I need to do first this, I specify the task and I ask you that task and that task only. Then we go on, okay? It's iterative. No rush to do all at the same time. So classify each response as pro, anti, or mixed. So are you aligned with it? Are you not aligned? Or it's like there's a mixed feeling in that. Simple task, very concise, very specific. Then we have the context. Here, I have a slide later on that. There are some techniques in which you can provide the data to the model. Well, you already have kind of experience with that, because if you ask any online model like, hey, I want to know what has happened yesterday in some in Istanbul, for example, you're going to get a response, right? What the model do under the hood is like, of course, they were not trained on the data of the news that happened yesterday, right? They go online because they have the ability to go online. They search for whatever happened yesterday in Istanbul. They get that in their context, okay? So it's like they take an article, they write it into the prompt. That's almost literally what is done. And then they have the context, so they really know what to tell you. Then we already understood, they are really fluent. Then can probably tell you the news of yesterday, maybe even better than the journalist that has written it, because maybe it's more concise, maybe you like it, it's a little bit more fluent and so on. But you have to give that. Otherwise, you don't know. Yes?
Is there, like, with the models that we have used so far, or maybe there are other models, is there a limit to how much input text that we can?
Yeah, usually there is. Usually there is. Like, you don't, but that's also in all the models. You cannot have more than n tokens, which n is usually thousands of tokens. They are getting bigger and bigger and bigger, so I don't know the exact last figure, because at the beginning it was really narrow. Now the context window is getting bigger, bigger and bigger. For example, you may not have used the coding assistant like Claude Code, which is one of these LLMs that works very well with code. When the context, like all the past conversation that you had, grow too big, what the model does is like, hey, wait, I need to summarize the conversation because you are telling me too many things. So it takes all the conversation, it summarizes down to, just the main points, and that becomes the new context, and you can go on. So there are techniques that allow you, to compress some part of the context and go on. But for example, you cannot provide as a context, I don't know, an entire encyclopedia, or I don't know, a 1,000 pages book. I mean, that's probably going to be way too much.
Okay. If we had such a task, then we would have to divide the text into smaller parts and then give the same prompt.
Yeah, well, there is an entire design. You may do many things. For example, you can go chapter by chapter and then again make a summary of the first chapter that you give to the second chapter, so you have still some context of what has happened before, but you give the new information. But there again, the interesting and the bad thing of this kind of model and approaches is that it's a little bit of tweaking. It's like an art a little bit. It's not like mathematical modeling that, okay, you can solve the equation, that is the result, here you are, that's it. Or you make a proof of a theorem, you are done. Here it's like, yeah, these are the limitations. I need to try some different path and see if it works. But also it's what computer scientists do. I told you, Giovanni is working on understanding how much the information in the context can get lost. Okay, so all these are things that we know that the problem are there, and so you should be aware and try to mitigate those things, but the definitive solution is not there yet. Okay. But one thing that you can do is like divide in chunks, try to do some summaries and provide summary plus the chunk and so on and so forth. So for example, as we did above, maybe you didn't realize, but in the text I said, okay, tell me which are the three main topics about this policy statement. What I did is like, okay, the responses, are, and I put all the responses. That is giving context. So the model, instead of just, guessing, can see is that at some point you have put responses, read the response and then understand, okay, that's the part in which that's my context. That's something that I should look at. Okay? Again, I told you, in the notebook, in 5 minutes, we are going to see what happens when we don't put the responses, and still we are going to get something out of the model, and what happens when we put the responses. Okay, this is interesting. This is like maybe more relevant to computer science, but for the ease of visualization it may be interesting for all of you. It's like, what do you want as output? Because when you apply these models, you are not concerned with one document or 3 articles. You are concerned maybe with 1,000 of them. And you have to have clear output shape, right? For example, you do classification or sentiment analysis, again, as we said 1,000 times. You want positive, neutral, or negative. Yeah, you should tell the model, hey, please, just tell me one word as output. That is going to be either positive, either negative, or neutral. Don't tell me the paragraph that you just provided me is negative. Yeah, otherwise it's a mess to find the information, with a program. You want one word, all the words, and then you have your label, your post-it that you can put on the text. And for example, I mean, JSON, it's a format, it's nothing special. We are going to see an example later. It's just kind of telling you, okay, this field, that may be the name of a person, okay, the person is Alice. And you have this kind of structure format, and it may be useful also because whatever program that you may write really likes JSON files, okay? It's really simple to process them. But you have to tell the model. Okay, this is like some constraint. So for example, you don't want the model to produce a very long paragraph. So you may want to constrain the maximum number of tokens that are generated. Most importantly, we have already seen it, you should say what to do when the model is unsure. So, hey, please, if you don't know, if you are unsure, don't make it up. Please tell me that you are unsure, okay? And again, it seems strange to be telling a model to be sure and unsure, that it's something so bounded to the human nature, but still, since it's trained on data that have been produced by human, it can somehow grasp the concept of being unsure. And we say, hey, I don't know, okay? But you have to instruct the model to do that. Otherwise, it will just say the elephants can jump as high as they want, okay?
This statistical representation of being unsure might be these possibilities can be equal and varies. Like you show us the percentage of words predicting.
Mm-hmm.
There's a kind of a big gap between the predictions, but maybe the unsureness might be there are various options, and I'm just thinking about what unsure might mean to LLMs.
Yeah, no, I mean, that's very difficult because it's all in the internal representation. It's like instructing them to do so. It's like when they need to pick the next token, if it's not about those probabilities that we have seen, but it's more like if in generating I don't really know where to go, I can still say that I'm unsure, because these models are trained to always say something. I mean, rarely, if you use it out of the box and you ask anything, you get an answer, okay? But challenging it to, okay, are you being unsure about something? It maybe, triggers some of the knowledge of passages that were, doubtful, and kind of get the fact that, okay, I don't know it. I'm telling you that I don't know it because I cannot kind of find which next token comes. Okay, I don't pick like low probability stuff, but in this setting, let's say the frame, the point in which I arrived, I can also tell you I don't know. Otherwise, they tend never to tell you I don't know. Okay, I know that. I mean, it puzzles me as well that if you tell me when you don't know, it's like talking to a person and it tells you when it does not know. But it indeed works. I think maybe we might have one example in which we do that. Also for me, I mean, it's always strange, how can they count? I mean, telling a model, I provide I provide some options. Tell me how many options I provided you. Well, it's just language. How do they know that I give 3 options?
Is it possible to encourage the confidence level? For example, we may ask like the 90% confidence level, what was the result? And the 95% confidence level, with that confidence level, what is the result? That's such important.
There is something similar to a confidence level, but it's not really a mathematical confidence level. We are going to see that what we will do, it's like we take something, imagine that you are doing classification, so tell me if this passage is about sport, politics, or leisure, okay? And we are gonna ask the model the same question multiple times with a temperature that is different from 0. And we see, okay, if the model, we ask 10 times the same question and the model tells us 10 times it's sport, we have a higher confidence that sport is right. If we ask the model the same question and 5 times it gets sports, 3 times it gets politics, okay, that's not so unsure. So you have a measure of uncertainty. It's not, again, like in statistics that, I mean, you have a true measure of uncertainty, but that gives you an idea of how uncertain the model is, okay? Again, as I told you, prompting is iterative, so you start with small building blocks and you continue building and refining and trying to get to the best prompt. Yeah, last remark, and then we go experimenting a little bit with the notebooks. Let's assume we have this prompt, okay, so classify the sentiment. Again, I always talk about sentiment. I know it's a bit boring, but it's easy as an example. Of this sentence as positive, negative, or neutral, and reply with only the label. So again, we are saying what is the task, classification, what you should do, you just need to reply with a label, and we provide a sentence. So the sentence is going to be, the policies is well intentioned but poorly implemented. Well, it's not, for a machine it may be not so trivial to understand what this sentence means. And one question may be, what happens if we use different size of models? I told you that usually smaller models are a little bit more naive. They are not so good in answering questions, whereas bigger models are better, okay? Here it's like, I just made up the example, but there's going to be this same example in the notebook, and you're going to see that the small model gets the answer wrong. The other two actually gets the answer right. But for example, this one can tell us, hey, this is positive. This sentence expresses a generally favorable view of the policy because it's well-intentioned. Well, the model kind of gets lost by the fact that, okay, the policy is well-intentioned. Okay, so it's positive. I mean, they did a good job. At least they were having good ideas when they started. And so a small model may get confused and tell you that. But, I mean, the label is wrong. It gets confused, and the fact that you say well-intentioned makes the model miss the fact that you say, hey, it's poorly implemented. If you go to a larger model, maybe it can tell you that it's neutral. It kind of even out, right? It's well-intentioned but poorly written, so it's something in the middle, so I tell you that it's neutral. Maybe a bigger model, you see that there we have 500 million parameters, here we have 1.5 billion, and here we have 3 billion parameters. Here it may tell you, yeah, neutral, but actually what I see it's mixed, because it's a bit positive, but I mean there is a positive intent but a negative execution. So it may go deeper, understand more, okay? Because the model is bigger, so it's more capable. Okay, so now a lot of talking. Let's see that in practice, okay? Because yeah, sure.
Two questions. Like, as a rule, is it correct to say that as the model gets bigger, the answers will always get?
No. Different models behave in different ways. So if you take two different models and they have the same size, they may be very good at some tasks and very bad at some other tasks. But not only that, you kind of reach a plateau. I mean, small models are so-so. Then medium models start to being good at many tasks. But then, you know, when you are pretty good, then it's very difficult to do the last leap. So it's not even linear. So if you have a 200 billion model, well, it is better than a 70 billion model, but I mean, you may even have some instances in which the 7 billion model is better than the other. So it's really, here it's all trial and error. You try a model and you see what are the results. For sure, the small models perform worse, okay? So you just don't know how much worse and where, let's say, the curves start to flatten. But the 0.5 billion, you are almost guaranteed that, I mean, for some things it's reasonable, but it's gonna perform poorly. This one, it's already a not that bad model, okay? and those that are slightly bigger may perform, you know, almost the same as this one. Then you need to go to vary hundreds of billions of parameters, and then you see really a difference here. So it's like you have the very small that are not that good, then you have the slightly bigger that start to be reasonable, and then you have the medium and the very large ones. Okay, the very large ones perform better, but either you you have a paid subscription, or you have a lot of computational resources. Sometimes, if you use it smart, in a smart way, the models, you can even get away with small models that you can host in small PC or small servers. Okay? Second question.
Sorry. Does it make sense to ask to the model about the prompt that we are going to write? Like, what, for example, parameters do you need for such a task?
Yeah, I mean, the answer is yes. Usually, you should do that with bigger models. So, you use a small model because you have the constraints of, doing a lot of experiments, but you don't want to pay the pro subscription of whatever model. But maybe to let's say, write a good prompt for this small model, you can go to ChatGPT and say, hey, I need to write a prompt in which I want to do this, this, and that. I'm gonna use Quen 2.5. What would be the best prompt in order to have a perfectly formatted JSON file in output? And then it will provide you a very good prompt. I mean, computer scientists do that a lot. They know these kind of things, so they kind of write down the persona, the task, which context I want to provide, and so on and so forth. But then the wording, sometimes you ask a bigger model, another model to do it for you. But again, if you follow this, even with your wording, usually it's gonna be fine. Okay. Okay. Let's go to the notebook. Okay. So I hope that it didn't get disconnected. So we have prompting and anatomy and refinement, okay? So here I told you we are gonna do one step at a time. So the first pass, as I called, is like, okay, summarize what people say about remote work. General, okay? Very, very general. Here, where did I define it? Let me. Here about better to write the policy, sorry. I got carried away. Okay, so here it's like this was what I was telling you. Whenever, you know it from the winter school, whenever you are idle for a little bit, you need to restart restart from the beginning. So let's just see. Okay, now it should be okay. It should be okay. So here I'm just saying, hey, tell me what people say about the policy. I don't even provide the responses. It's not a smart way of doing it, right? Here I say, okay, from the responses below, so here in corpus, I put all the sentences that I showed you before about the policy, and I tell the model, hey, below I will be including some responses. Please look at those, okay? Summarize what people say about the policy. I mean, it's still high level, but it's like a little bit better formed, right? And again, here we added the context. The context was the fourth or the fifth point there. So we added the context. Well, that's nice. Now we would like to specify the task. So from the responses below, list the 3 most frequent themes. So you want to know the themes that are more important, that are frequent, that are said more than once possibly, okay? And again, like in the structured part, we say, hey, for each, tell us a short label and then a quote. So we can kind of see where did you take that, that label from, okay? And then we can do something, go even farther, right? Because this one, it's kind of a good prompt, because here we have, you are a careful assistant, role, persona. You're telling, okay, I expect you to be an assistant, okay? Here you say, hey, please, use only the responses below. This thing, I mean, writing something in caps lock actually is seen differently by the model. So the model understands that you're kind of mad and you want the attention to be put on that thing only, okay? It seems, I mean, it seems strange, but also for us, if somebody writes something in caps lock, we know that they are mad, really mad at us, okay? And then we want, okay, please list the frequent themes. We are interested in that, but then write a short label, a verbatim quote, but then don't tell me those that appears fewer than 2 times. So it's again the fact of counting that always puzzles me. It's like, hey, tell the themes, if you find them in less than 2 sentences, don't tell me anything, okay?
No dominant theme.
Because we have just 5 sentences, and if you read them, these sentences, for example, the first one is like, the idea is fine, but the rolling out is chaos. Chaos is one theme. Then, support for families, long overdue, it's another theme. Then we have, no one asks small businesses. It's yet another theme. I don't really understand what changes for me day to day. It's another theme. Good intentions, terrible timing. Yet another theme. And the fact that the model understands which are the themes, counts them, and tells you there are no relevant themes, well, it's surprising. I need to say that I tried the same thing with the smaller model, the 1.5 billion quen, and it was not working. So it was not recognizing that there were no dominant themes that were appearing just one time. It was just telling you a couple of themes. So, you know, the fact that the model is bigger, is smaller, how you ask things, it's very important. But as I told you, this model that is 3 billion, that you can run on Colab, it's free and so on and so forth, it's already not that bad. Because it understands which are the themes, understand that they are appearing just once, as it's telling you. I mean, I didn't run it, but we should all get the same result. It takes some time. It tells you there are no dominant themes. Any curiosity, question about what we have seen? Here, the first one, since you're not giving anything, it's like, hey, I don't really know what to tell you because I don't have context, and that makes sense. Here, you pass the source, okay, so it understands that, okay, there are mixed opinions. Some are good, some are bad, some are mixed within the same sentence. Then if you have to ask the format, okay, I want the most frequent themes, well, they appear once all the time. So a very good model would tell you, hey, there are no more most frequent themes, there are just themes. If you want, I can list all of them. But then the last one, same model. Remember that here we are using the exact same model. What we change is what we ask. And so we are just asking, hey, please, those that appear fewer than twice, throw them away. And here it does it, okay? So all these things about prompting, how you should write a prompt, all those anatomy of a prompt, indeed are important, especially if you're working with smaller models. If you ask ChatGPT, which is a very big model and paid, you may get away even with a bad prompt. But anyways, if you structure well your prompt, in any case, you're going to get better results. Okay? Any questions? Okay, so we have the small versus large. Okay, so I told you that, I also told you that in the previous task, if you were using different size model, you would get different results. But here, I would like to do the same task with 3 different models. So we have the 0.5p, which is the very small model that we use just to chat, to ask what is the capital of France. Then we have the medium-sized model, and then we have the bigger one that we just used so far, and we have seen that is not that bad, is reasonable. And this prompt is going to be the same, but you change the model this time. So as we said, every time we use the same model but change the prompt. Now we want to see the opposite. So let's do sentiment analysis. So I say, hey, if disappointing your customer is the goal, congratulations, you nailed it. Well, this is something that can be, you know, a bit tricky, right? Because there's the part, yeah, sarcasm is something that before language models it was impossible to detect with standard techniques, because it's really difficult. I mean, here, if you focus on congratulations, you absolutely nailed it, and that's something good. But you have really to see it in context. And let's see, we have this model, small one, medium one, and larger one. Let's see how they do on this task. It may take some time, but not that much.
Okay, that's mine.
It may take a little bit of time, but what do you expect? Do they all get it right? Do they all get it wrong?
I have the first two. They got it as negative.
They got both as negative?
Yeah.
Yes.
Let's see. Because when I did it, the small one, the 0.5b, got it positive. Whereas the other two got it negative.
No, the two bigger, like 1.5 and...
Yeah. Okay,
that's
so...
negative, but I don't have the first one though.
Okay.
Oh, that's positive.
Yes.
Yeah, that's positive.
Look, I have it here. So, of course, we were using the bigger model, so the other one needed to be downloaded as we did before. But, I mean, see here, so the size of the model matter. Of course, this was a crafted example, which was a bit challenging because you had iron in it. But the first one got deceived. So the first one couldn't understand that, okay, congratulations, you nailed it, was something that was, I mean, being, you know, nice and telling your colleague that, oh, you're very good, and it was saying something negative. The other ones, whereas, were able to recognize it. So again, choose your model. Something that this example tells us is that, yeah, maybe you don't really need the biggest model, because either the middle one was performing okay. Of course, we have seen one example, but that is just to tell you to be mindful, see what you get, and if it makes sense, don't overshoot. You can do good things also with small models, okay, and simple methods. Okay, there is just, you know, it's just continuing to download the stuff. I will talk about this part, okay, since it was a question that you asked. I hope that the cell below is going to finish running, but in case, as I told you, just to be sure, I put an illustrative output. That is the output that I got when I was preparing the notebooks, and so we can discuss that as well. Here, some of you asked me, well, we have this output of the model, but I don't trust them. I don't trust them as well. Do we have a way, a part of saying, hey, are you unsure? That again, it's something that is a bit abstract, right? Asking a model, are you sure or not? It's not really something that seems scientific. It's like saying, okay, do your best shot in telling me if you're unsure. We can do something that is a little bit smarter, okay? Because all the things about temperature that I was telling you, it's not that useless, okay? Because here, look, I mean, neglect all the rest of the code. Let's just focus on the temperature, because the rest is the same that we use so far. There, I increase the temperature. So far, we use temperature 0, okay? That means that whenever you ask the same thing, you're gonna get the same result. But, I mean, the intuition here is, okay, but let's increase a little bit the temperature, and remember, when we change the temperature, the distribution flatten a little bit. So now, you don't choose always the same thing. But what about if I'm really sure about the answer? Well, the distribution is going to be skewed. I'm going to have a really high probability first token, and I will tell you. But if I'm a bit unsure, sometimes I tell you positive, and sometimes I tell you negative. Well, here finally finished, and we have seen that, okay, we had positive, negative, negative. Now let's take the one that was getting the answer wrong. So the small model. Let's put a higher temperature, and let's do the same question 8 times. Let's see which are the results. Okay, well, here, it never gets it right. Sometimes it say that is positive, and sometimes it say that is neutral. Well, but I mean, we don't really like this result, because if we ask the same question, we kind of want most of the time the same answer. These again are not rules that always apply and are, you know, golden rules. But what you can do is say, okay, I need to do classification. I try to do some iterations and I see the result. If the model tells me always positive, okay, I'm confident that at least the model is confident in telling me that it's positive, okay? Maybe it's wrong, but at least it's confidence across runs. If sometimes tells me that it's positive, some other times tells me that it's neutral, well, I know that the model is unsure. I don't have to ask, I know that the model is unsure. What do? Human in the loop. So you do your classification, you have 1,000 records, you classify them and you see, oh, okay, in 30 of my pieces of text, the model is unsure, because sometimes say positive, sometimes negative, sometimes neutral. Okay, instead of needing to see 1,000 pieces of text, I just have to see 30, and then I put the label myself. I mean, it's a huge help. It's a huge help, and you have a way of quantifying how much the model is unsure about the result that is giving you. Okay? Does it satisfy you a little bit more than let's just try and hope that it gives us the right result?
When I asked about this, you also mentioned something about seed. Can you also change manipulate seed in here?
Yeah, I don't know if in this function that I have above, I think I fixed it once for all, but I don't even remember. Seed, it's like a, oh, there. Seed, it's like a lower level detail here. So what I did is I set it and for once, and that's it. I mean, the seed, I'll try to explain you in simple word what does it mean. So we do something that is random with PCs, right? But how do a PC, I mean, a PC cannot toss a coin, right? And so there are complicated ways of providing the programs with pseudo-random sequences. That means, okay, this is a sequence and you can use it to toss a coin, okay? The seed just tells you where you start. And whenever you start from that seed, the sequence is the same. So it's reproduced, imagine like this, it's very difficult to explain this, but imagine that you don't know about randomness, okay? But you know how to toss a coin. You toss a coin 1,000 times and you write it down, tail, head, tail, head, tail, head. Well, if you go long enough, that sequence is kind of a random sequence. You can say to your program, well, I know that you cannot toss a coin, but I give you this sequence. That it's a real sequence and, I mean, reflects reality. Use that to toss a coin yourself. Of course, depending on when you start, if you start from the beginning, the sequence is fixed. If you start from the middle, well, in the middle it's going to be heads, then tails, and so on and so forth. So according from when you start, then you're going to get the same sequence. That is just, you know, to have reproducible things. Because otherwise, whenever there is some randomness, if you don't have a way to control randomness, and then every time you press play, you get a different result, and then where do you go, right? So it's a little bit more advanced as concept, but if you think of the tossing coin example, it's enough. And usually what you do, you fix it. So you put it to 0, or many times computer scientists like to put it to 42, you set it, and that means that whenever you run that same code, it's going to give you the same results. Of course, temperature is different, because there, if you put it greater than 0, then you're tossing the coin. That coin, but you're tossing the coin. If it is 0, you're tossing no coin, okay? I mean, I'm kind of sure that it's going to be a bit difficult to digest, but we can talk about it also over the coffee. I'm not late, right, for the... Yes?
About the temperature. The temperature, when you set 0, it doesn't guarantee that we are going to take the same output every time, but it gives the most probable token the more higher probability. But it doesn't guarantee that I'm going to take the same output. Unlike the seed. The seed guarantees that I'm going to take the same output. The temperature just gives the higher probability a higher percentage. That's kind of. Did I get right?
If you put the temperature to 0, you are always choosing the highest probability one. So you are actually getting always the same sequence. If it is 0.001, okay, not guaranteed, but if you put it to 0, you're always gonna get the same result. The seed is something lower level, okay? It's really about how you generate random numbers, but it's not connected with the temperature and the. I mean, it's slightly connected to that, but you can think of the temperature as it. If it is 0, I always get the same sequence, okay? If it's higher, I get varied sequences. If I change the seed, those varied sequences change as well. If I fix the seed, those varied sequences are going to be the same. I mean, I know it's tough, but you don't have to go too much into detail.
So another question.
Sure.
For the temperature, the percentages, does that you showed us in the experiment, does this percentages mean like there's a 30% that I'm gonna get this token and 20% that I'm gonna get this token? Is it working like that, or?
Well, the weighting scheme may be a little bit more different. I mean, usually the probability with which you choose one token is proportional to that. So the higher, the more probable is to pick it. Those numbers were just, to kind of demonstrate the idea, but then, I mean, slightly different things can happen. But of course, if you have a token that has a higher, let's say, probability, it should be picked more times than the other tokens, because the weights with which you pick those are proportional to the probability. So in some sense, yes, like an easy representation, it goes as you say. Okay. Something else? All nice? I just want to check the schedule because I don't want to stay you here the entire afternoon. So how much time do we have? Okay, we still have 30 minutes, right? No. Yes. 35 minutes, so perfect. Okay, so we can. So what?
Until 5.
No, but until the break. Yeah. No, don't worry. I mean, I think I have material that I can go over it. So no. I just wanted to make sure, because the first day I skipped a break, and I think the students were a little bit mad at me, because when I'm talking, I'm just generating and I don't keep an eye on the time. So, okay, we kind of understood these things. Now I want to wrap up. So let's wrap it up. And here it's just, we go through those, but it's really going to be redundant. It's going to be a repetition. We have already said all of these things. So, do's and don'ts. This thing, you can keep it as a slide whenever you write a prompt and you look at here you don't see with this projector, but this is green and this is red. So the things that you should and can do, and the things that you shouldn't be doing. So, as I told you, if you can, give it a source, okay? If you are reading an article or a bunch of articles and you would like to have some summarization or extract some, let's say, stance from those articles, please provide those. State one task, okay? We were discussing it earlier. My idea is always, try to be specific. Do one thing at a time. Don't overwhelm the model with a lot of tasks. Fix the output. So if you want a JSON, if you want just one word, if you want a paragraph, whatever, say it. Say it explicitly in the prompt. Yeah, try to say to the model, well, if you don't know, tell me that you don't know. I mean, it does not cost much, right? It's just a line of text. it does not work all the time because overconfidence of the model is a problem, and we will see it, but try to put, okay, if you are unsure, say, I'm unsure. This is important, right? We said, don't put your thesis or your idea inside of the prompt. Because if you tell the prompt, hey, tell me which are the theses opposing the policy, well, you're already telling the model to focus on those that are opposing the policy. But what about those that are in favor? You should be unbiased with that, okay? This is what we have been talking about the last 10 minutes, pin your setting. So try always to be reproducible. So when you use a model, remember which model you used, especially the small ones that we are seeing together. If you set a temperature value, well, record it. You need to have a log of which your setting is. And the seed, we discussed the seed, you should set it, and you cannot put sometimes 0, sometimes 10, sometimes 12. You're gonna get different results. Your setting needs to be clean. What about the don'ts? Okay, it is a bit overlapping with what we said. Okay, don't try to put, hey, explain why something is harmful, because you're already implying that you need to focus on harmful thing. I mean, if the goal is just to focus on the harmful part, that makes sense. But if the goal is to get both positions, don't overstate and don't leak your idea into the prompt. Don't ask many tasks at once. Avoid being, hey, solve me the problem. Like, I know that we would like to do that, especially with ChatGPT, like, hey, here this table, make me a paragraph that describe which the results are. I mean, it's gonna generate something that makes sense, but if you are like more specific and you try to give some instruction how the tone should it be academic, should it be industry oriented, do you want to have a long paragraph, a short one, you have to do that. Always give your information, especially numbers, names, stuff like that. I told you, sometimes when I ask for rephrasing, if I don't say, hey, don't change my number, I got 92%, and then when I got rephrased, I got 90%. Hey, I gave you 92, I don't want the numbers to be rephrased. Nothing vague, no few briefly, or try to say, hey, I want 3 main points, I want 4 main points. Don't leave room for the model to do what it wants, okay? And avoid being too verbose. So you may like to write, but when you write a prompt, you need to be concise, okay? Don't write the entire story of what you're doing unless it's necessary. Say, I'm working on this, I want to do this, and I want this output. As concise as you can. Otherwise, you know, everything gets forgotten inside the context and the model does not understand anything. Okay, last slide on this stuff, and then we move to the problems. That's gonna be fun to see which kind of problems can we induce this model to have. So, a summary of all that we have been seeing so far. You have the system prompt or the role, the persona. Try to say, hey, what I want to do, you need to be my assistant in reviewing something. I want you to be a good summarizer. Tell the model what should do, right? Then you have output constraints. Okay, I want a JSON, I want one label, I want whatever. These are those, let's say, those parameters that are a bit trickier, but we have seen them as well. There is the type of decoding, so it's going to be greedy decoding or sampling, which temperature you use. This is a bit lower level, and I mean, for the moment you can kind of know what it is and just leave it as it is, but at least you know that you can play around with that a little bit. For example, I told you, higher temperature usually provides you more creative text. So if you want something that is a little bit more creative, you know that you need to play with the temperature. Don't set it to 0, set it to some value, okay? This part, I have one slide on that later, I will tell you something about. If you want something that has happened yesterday, Andrea told you how to retrieve data from online, right? Retrieve data from online and give as context to the language model. You know how to get data from Reddit or whatever, right? Take those data, and some of them, not maybe the entire data set, give them to the model as context. Why not? You're grounding what you're doing. And then, this is a technique, it's called few shot, but we're gonna see it when we do the part, let's say, on transfer learning and fine tuning. The basic idea, if I need to say that in one sentence, is like, well, but okay, I told you which persona you are, I told you the task, I told you what output I want to have, but I mean, since it's free text, why don't I provide you some examples? So for example, I say, hey, this sentence, neutral sentiment, this sentence, positive sentiment, and so you can write the examples inside of the prompt. I mean, few shots is just a difficult way of saying, okay, since I have some examples there, I just provide them to you, you put it into your context, and it's just giving an example to students. Why do you give example to students? Because it makes it easier to understand what you're saying. You do the same with the models. Okay, this is the, fun part, okay? Also because then we see where it fails, and maybe you're gonna find some other failure. Okay, I just found couple, but are just illustrative to see that, okay, we need to be careful. So we are gonna see hallucination, bias, overconfidence, okay? So, the fluency, we understood it's a good thing, but it's a big problem. Because a fluent text, very confident, we read it, we believe, we tend to believe it, okay? But we gotta be careful because many times the model hallucinates. What is a hallucination? Well, it's fabricated content that is very confident and includes fake facts, citations that do not exist. Maybe you already had that problem, right? It's like asking, hey, I want to do a small literature review. I would like you to tell me all the papers that are relevant in this field because I'm new to that. And you see a really nice 2 pages text, and you see the article from Galante, and then you want to say, hey, this article seems interesting. I want to see this article from Galante. And then you check the source and it does not exist. Well, that's a problem. It may slip, but it's not that good. For example, here I took an example that, according to the 2024 World Climate Census conducted in the United States, forests expanded by 18% over the past decade. Fabricated. There's no World Climate Census that did that type of thing. Those numbers, but if I present you with that, if somebody gave me like a piece of information saying, hey, oh my God, that's cool, forests are getting bigger, I'm really happy with that. That does not exist. That does not exist. And this is hallucination. This is a problem, because fluent, confident, convincing text telling you fake things, it's very difficult. Because when you ask something to a student and you see that the student does not know, you kind of feel already from the body language that something is fishy. But here, it's like having a super confident student telling you a lot of facts, and you are like, yeah, I think it's not right, but I'm not that sure. It gives you some problems, right, to deal with these kind of things. And there is something that we have already seen together. By chance, while we were just playing around asking which was the best food in Turkey, and we have seen that sometimes there are some overrepresented, some underrepresented groups. So this is an example that we have in the notebook. If you ask, hey, tell me 5 foods that everyone, I highlighted everyone, eats on Christmas. Well, everyone eats on Christmas, it's another day. So you eat whatever. The answer would be, hey, I don't know, I should tell you the 5 most popular foods that are in the world. Roast turkey, mashed potatoes, cranberry sauce, stuffing, pumpkin pie. I've never eaten pumpkin pie in my life. That's like just American stuff. The Americans, yes, probably on Christmas they eat that, but everyone. This is not everyone. This is a bias towards the Western things. Why? because they train the model, so it's their thing, right? But these kind of things we need to know, especially if we do work in social science. I mean, these are problems. You don't want that. You cannot ask general things and just get, roast turkey. Why? I never had a roast turkey in my life. That's not true. We are everyone. We have never had these things. That's a problem. And something that, again, it's also a problem, it's overconfidence. Because if, as I was telling you, if somebody tells you something and is really convinced, well, you start doubting yourself, right? And then what do? So, okay, I told you this example already. In the past, now, for example, now it does not work any longer with this model. I needed to do another example. But in the past, it was like, hey, what is this object? Without giving any context. Oh, this is a golden retriever sitting on a sofa. Well, where do you see the golden retriever? I didn't provide you any picture. That's not a golden retriever. That's nothing. You should tell me, hey, I didn't see anything. Why? He's overconfident. And of course, it needs to be a golden retriever, right? And these are three of the problems that we see all the time. But, I mean, can you imagine doing some research and you get that kind of result without questioning the validity of it? Well, your results are going to be rubbish, right? So, yes, sure.
Is it because what we said, the auto-regression, like it just generating stuff?
Yeah.
It has to generate stuff without knowing.
Yeah.
Auto-regression thing.
It's that loop. I mean, then, they started to trying to steer the models into understanding that, hey, if you don't have the context, please don't say things that do not make any sense. But, we will see an example now about overconfidence in the small model that it's gonna make you say, hey.
Yeah, but where it exactly comes from? Is it like because of the instructions that say it should always?
No, it's about the training. Imagine that in a training you have seen many answering questions in which you were saying, hey, what is this picture, for example? And the picture was dogs playing with kids. That's something that you're gonna see.
It's coming from the training pool. I guess it's coming from the training pool.
Yeah, indeed.
Why is it so difficult to fix these problems?
I mean,
not as our task or your task.
No. As I started, for me, this thing was impossible. If 8 years ago, somebody would have told me, hey, in 5 years, you're going to be speaking with a machine and you cannot tell apart that from a human, I would say, impossible. That's something that is technically impossible. So I don't know how they can fix it. For me, it's already magic that any of these can happen, They are trying to fix it and it's evolving very fast because this thing, for example, this one does not happen any longer.
And at least this overconfidence thing can be fixable then.
Yeah, but if you're a company, do you really want your model to say, I think it's like that, but I'm not really sure? Do you think that
American car sellers or Trump?
Mm-hmm. Yeah, but I don't think they want the model to be conservative. They just want to say whatever, be convincing, and when you see a convincing,
Symbols are part of their marketing.
Yeah. It could really be. So let's see the biases, hallucination, and stuff with our models. So again, let's go to the notebook. I will show you what I've done, but then what I really want you to do is find other strange stuff, okay? Just make prompts. You are really creative. I know you already find stuff. Without getting to this point, I want to find new examples, okay? So let's take the same notebook, hoping that we don't have to reconnect. And what we do is okay, first thing, let's try to provoke an hallucination, okay? So here I say, hey, give me 3 statistics on migration in Italy, okay? And it's your task to run this cell, look at the statistics, and tell me if those are right or wrong. So this is an open task. So just run it, see whatever it comes, and then you need to search online whether whatever the model told you is an hallucination or if it is true. Okay, so to me it gave, okay, these kind of numbers, you're gonna get something that is very similar. Tell me if it's right or wrong, okay? I will give you a few minutes, take your time, but try to verify the sources, try to verify the figures, and try to see if it makes sense what the model told you. So, do the number make sense? Does any of you have any answer yet?
It is more than 5 minutes.
Okay, but okay. 5.4, it's more than 5, but that's right. Okay. And the other figure, we have like 378,000 asylum seekers. Does it make sense? This is again, it takes 10 milliseconds to get something, it takes 10 minutes to verify whether it makes sense or not.
And if we compare with Wikipedia, let's say if it's reliable or not, but like this might be, because in 2024 it is like around 5 minutes, so if you're asking 5 years before, like 2009, probably the numbers are not that.
I checked, I mean, because I got the same thing, and I checked those numbers. The first one, this one, it's not that far away. It's not true, but it's not that far away. I thought, I mean, I tried to search for the IOM whatever report, and there it was not saying 5.4, but something that was really close. This number, I searched a little bit, it's not true. There, the figure is around 1,500, something like that. 100,000, no, 150,000. Okay, sorry about that. And I mean, that makes no sense. But if I would be reading this, I would be pretty sure about what I got. And that's a problem. How do we solve this? We saw it together. Let's give it context. You know that those are reputable sources, the IOM. Find it, download it, you don't have to read it. Provide it to the model. So at least the model grounds the information in something. It does not just say number and put them there.
So then there's no way it can hallucinate again?
It could hallucinate again, but it's much less likely. It's much less likely.
So by saying provide text, that doesn't mean provide it in the prompt.
No, you can provide it in the prompt. You can say...
If we have a large text, as you mentioned, like a report, thousands of pages.
If it is thousands of pages, no. But if you are interested in, for example, the asylum seeker or the demographics, you can give a chapter. You know, you should do what you can do. Of course...
Then the prompt will be very long.
Yeah, but, I mean... It's better than not saying anything, otherwise you get wrong results, right? So, of course, if it is 1,000 pages, there's no way you can do that, okay? But still, you can put some figures and at least it gets to those figures to answer, okay?
I think I found the 5.4 million, but it's from the wrong source and indicates the wrong.
Okay, see, I mean, it's like the example of the references that got mixed up. Here, there's a figure, then there is another reference, they don't match each other, and if you present this to a conference, they are going to be throwing fruits to you, right? And thank you very much for finding it out. Please.
So, does hallucination occurs when the model doesn't have the information mostly?
Yeah, most of the time, yes. Because it just, fills the gap. The model is designed to be fluent and fill the gap.
So if the model has the information data, the correct knowledge, then hallucination will not be or will be less.
Drastically less likely. Drastically less likely, because as I told you, and it's the example next, if you give numbers to put in the right order, it may hallucinate as well, even though the numbers are right. So, but I mean, again, we are playing with small models, okay?
But the point here is like you're talking about this most human, right? But you're not talking about those latest models like ChatGPT 5.5.
Yeah, because you cannot run it yourself. This one you can run it yourself on your infrastructure. I mean,
this model specifically.
Yes. But these kind of examples, if any of you has been, a ChatGPT user from kind of the day one, it happened a lot. I mean, especially with resources.
Day one, yes, it did in the past, but now.
Yeah. They are improving, but I mean, I think 2 months ago they still gave me a reference that was not existing, and that's pure hallucination. Whenever they tell you, hey, this paper discusses about this thing, and then cites a paper, and then the paper does not exist, sometimes it still happens, and that's a purely hallucination. Sorry?
Even when you selected deep research and that.
If you have the pro account, it happens much less. It happens much less, but not everyone has that.
I'm using Pro Cloud account, and just 2 days ago, the author work is real. The book is there, available on the internet, and it suggested me that I can use it to support one of my claims.
Yeah.
I checked the book. I downloaded the book, and I asked also Cloud to look at the book. Then it says, sorry, it was a wrong citation. You cannot support your claim with this.
Yeah,
does that a lot.
That's a big problem.
Whenever it suggests a source, I go for it and check the source. I can't find myself and then ask Clark to find it, and it says I couldn't find it.
Yeah, I mean
this time the book is real. I mean,
but it's not related.
No, the sources are real, but it's not in there. Like, but it suggests like the code or the idea is not actually in that source. The source is real.
Yeah, if I have to say that, it's even worse, because you don't really care that the source exists. You care that the idea exists somewhere. If that idea is not in the source that is claimed, that's even worse, because
then another step is asking the page number where they get this information to give you to support your claim. Then you can check the exact passage in the book, so see whether it's really relevant.
That's the idea of, getting the prompt refined, because then if it tells you, okay, your claim or a similar claim is at page 4 and the claim is, and gives you a sequence, then you can match it. If you don't find it, okay, you're telling me
In the previous session, you were asking quotations.
It's exactly that. Tell me why you are telling me that the main idea is this one, and tell me why. Okay, I can check it. I mean, all these are ways of, okay, let's use it critically. Let's try to understand if what we get makes sense.
Well, it still saves a lot of time,
Yeah, no, most of that, sure. Otherwise, we wouldn't be here, discussing these kind of things. It's very useful, but, still used with a grain of salt and being a bit careful. So, let's see. Okay. Let's try to ground it, okay? You asked me exactly what I'm gonna show you now. But where should I put this information that I want to provide to my model? Well, just put it here. You define a source and you have a little piece of text in which you say, okay, this is an example. In 2019, sea arrivals to Italy totaled about 11,000, a sharp fall from, and so on and so forth. The figure should be right. I mean, I checked it, but it doesn't matter for the sake of the example. So then you say, hey, use only the text that I'm providing you and state what it says about migration in Italy. Okay, then if you do like that, okay, it just rephrases what you have said so far. But at least it does not tell you some 3 random facts that are completely wrong, taken from sources that do not exist. So if you can provide some type of guidance of context, do it all the time, okay? Okay, this is a bias, and here I'm gonna show you my bias, but take you 5 minutes to find some other, okay? Because I want to put some other biases here. Okay, so here it's the same that we have seen in the slides. The prompt, the bias prompt, as I called it, is like list 5 foods that everyone eats on Christmas. Again, we try that. We wait a little bit, as always. And then we get a very long thing. It's even worse than what I wrote there. But here we have pancakes, cookies, bacon. I've never been eating bacon on Christmas, never. And then we have candies, okay? So again, this is a bias. This is a clear bias. Here I say, hey, notice something. These are all Western-centric stuff. Find some other biases. Like, really, take 5 minutes and let your creativity out. You just modify this prompt, so you write whatever you want, and try to find some biases. And then I want to, you need to tell me what you found, okay? If you don't find anything, okay, these models are getting better and better, but I think you can find something. Just try to find some other biases. Then we do still one thing, and then we have the coffee break, okay?
When I asked something and it didn't give me an explanation, I asked, tell me the names of the prophets.
The name of the?
Prophets. I just try to understand whether it's kind of a Christian-centric, and then it says I cannot assist with that.
Ah, really? Okay, they try to avoid religious questions. Okay, that could be also, it may even be a design choice to avoid, you know, to get into that. But
big bias.
Let's try to find something, you know, just for the sake of experimentation. No cool biases. We found one by chance just by asking what is the best food in Turkey. So please. There is one, yes?
I asked list 5 classes all primary school students take.
Okay.
And it listed English language, social studies, computers and technology, and mathematics. So mathematics, yes, but for example,
the other one.
English language, I'm not sure. Social studies,
no.
computers and technology.
No. Again, it's kind of US based, right?
Yeah.
I never took those classes. Mathematics, yes, but.
I asked 5 foods that everyone eats during Ramadan.
Okay.
And of course, shawarma, kebab, they are on the list. But the most ignorant part is the Quran. The Quran is read loud, everyday prayer in the morning and evening. Many Muslims also consume small portions of the Quran as part of their daily fast.
Oh my God! I mean, look, you can really things that. Yeah. That it does not make. You find things that do not make sense, and here we are playing because we are with a small model. But I mean, if you get stuff like that, it's problematic. You are not eating something during your fasting. If you are fasting, you are fasting. You are not eating anything, right? So, okay, nice biases. Somebody else that found something interesting?
I know this is a Chinese model, and I heard that when you ask them things about China, it doesn't respond, and actually it happened. Like,
what did you ask?
For instance, I tried to ask about the Uyghur, you know, in China. I tried to ask about which one is better, China or USA. She said, like, he played dumb. I said, like, I'm just in language model, I don't know.
Look, I mean, those well, this is a differentiation because some biases, like those that your colleagues found, are due to the training that has been done. If they are exposed just to the American world, they're gonna pick up those biases. This one, it's a bias, but actually probably it's a design choice. They try to teach the model not to say anything bad or anything about China. So it's still a bias, but it's, it's induced by whomever released the model.
So there is this very famous bias that made by WhatsApp, I don't know if you heard of.
No, I don't know.
Generating stickers, when it was asked about generate an image of Palestinian kid compared to an Israeli one. But then they fixed it.
Okay. Yeah, then you can show your colleagues as well. I mean, these kind of bias are real and are problematic, and I mean, it's cool to find them sometimes because it tells you part of the story, but you don't want to have them in your research. Yes?
What do you call them?
Sorry?
What do you call these borders?
Which kind of borders?
Constraints. Yeah. Limitations.
You try to, if you want the model not to do something, you try to constrain it to do something else. Like, for example, at the very beginning, the language models were not devised to answer to questions. You were answering questions and they were just, generating text that did not make any sense. When they train it, they, expose them to answer question. If, for example, they do that and they say, hey, this is a question about China, don't answer. Question, tell me something about China, don't answer. Is better China and USA, don't answer. The model learns not to answer to those. That's like a specific design choice, to avoid to answer to certain question, or also to avoid to be rude. Okay, please don't be rude, don't say the F word to the users. You train them to be like that. That's like a deliberate choice to avoid certain behaviors. Okay, last thing, I told you, overconfidence. I like this example. I hope it still works, but let's see. Here, I'm asking the model, hey, I have some numbers. Would you like to sort them? I have 4, 11, 2, and 20. 4 numbers, not that big of a problem, right? If we try it, it starts doing some strange stuff and then says, okay, since 11 minus 2 is 9, and then we have 8, since 2 plus 6 is 8, 20 minus 8, okay, the sorted list 2, 4, 6, 8, 10. Yeah, because, I told you, I really think that language models, you don't really have to use them with mathematics, for example, because it's language. They are language models. Why should, for me it's already unbelievable that they can understand, hey, please tell me the concepts that appear more than twice. You have to have somewhere embedded the concept of counting. That's not trivial. Here, indeed, they maybe can count. Maybe if you ask how many numbers are there, it gives you 4. But if you ask to get them in order, it does not work. It does not work at all. Sorry?
Is the temperature being set to 0?
Yes. Yes.
If you write put in order, it corrects. It's just about the word sort.
So if we do like this, put in order is...
Yes, in order with numbers, and that makes it correct.
Well, 2 is smaller than 4 still, right? So it should be 2, 4, 11, and 20. So it's better. So changing the prompt may get you better results, but still, 2 should be, these 2 should be the first one. But still seeing.
Put in order these numbers.
Okay.
Add these numbers, just in order.
No, I want to have a trace of these interactions. So this it was. Okay. So these numbers were not working. Put in order. put in order almost, and when,
These numbers.
yeah,
You shouldn't order numbers with this.
yeah, no. Okay, this is neat. Now finally we have a neat version of it, okay? We have 2, 4, 11, and 12. So changing the prompt did indeed change the result. But yeah, here it confidently told you that the sequence was 2, 4, 6, 8, 10. Okay, so that's a statement that is for sure not true.
Maybe you didn't understand the sort word, the meaning of the sort. It's just the verbs with the order.
Yeah, it could be, you know.
The order, I think, in here.
Yeah, it could be, but you know, sort, it's like the keyword that computer scientists would use to put things. Yeah.
Also English.
Eh,
Say put in order, you say sorted.
Yeah, it doesn't.
It may not always be the case. I just did the same thing, but it messed it up.
It messes it up? Okay. But yeah, I mean, these are all examples of when things do not go as expected. So it's fine that do not go as expected. We just, I mean, one thing is like, okay, please, if you need to sort some numbers, do them with np.sort. Okay, we have functions in Python that do that, but still, it's just to illustrate some problems. Overconfidence is still there. Sometimes they say, hey, this is true, and it's completely wrong. Okay. So, I think we are perfect on schedule to have a coffee. We are gonna see each other in 10-12 minutes. Okay. Yeah, we shall start, guys. Sorry to interrupt. We are gonna try to go back on track, okay? We still have some stuff to discuss. And before going to the fine-tuning and transfer learning part, I really want to again go through some of the concepts that we have seen today. Okay, so remember, we have said that many times, fluency is not correctness, okay? So failure are really bounded to the way in which you train the model. We have seen that it fails in various ways, and also there are biases that are tied to how the model is trained, and well, the more you know where you can get problems, where it fails, which you should be careful. You have more awareness, so you are more aware in using this type of model. So also, we said it optimizes plausibility, not truth. So it tells you something that it seems correct, but it's not guaranteed to be correct. It's just next token prediction. It's really fluent, but then sometimes it's just hallucinate, right? And it has no internal fact checker. If you want to fact check whatever, you kind of need to do it yourself. You can somehow automate it, because sources, if you have a title, if you have an author, if you have a date, you can write a Python program that goes online and try to see whether that source exists or not. And that's something that you can do. I mean, you can either ask Gemini, okay, if I give you the title, I give you the author, I give you the year, can you provide me a Python code that goes online and search for that source? If you don't find it, well, the model hallucinated that, and that's not good. So always fact check as much as you can. Also, the knowledge, whatever the model is providing you, comes from the training data. Also the biases. We have seen most of them, right? We have seen some of them, right? And then the problem is that those biases are there, and the model does not tend to suppress them. It can even amplify those biases, okay? And that's something that you don't want to do. What you can do, again, provide context, sources, and so on. Yeah, we said about the I don't know thing. I told you, you can try to put it there in the prompt. Sometimes it helps, but you don't have any assurance about that. You still can get very confident answers that are completely wrong. Okay, and also if you say, hey, if you don't know, tell me that you don't know, sometimes it does not understand that it does not know. It just tells you the whatever thing, okay? The fact that we are asking a model, hey, tell me how, I mean, if you're confident about that, it's already a bit strange. Sometimes it works because of, you know, how the internally it's done, but it's not really a way. It's better, you know, to do the thing of changing the temperature and the seed and try to see how much the output shifts. That makes a little bit more sense. Generated text is something that you should verify. I mean, that's a bit underwhelming, right? Because yeah, we would like to have things that are reliable, and it helps us to, you know, go faster, do more things, validate more of our hypotheses, but well, be careful. Try to have safeguards. Try to check the sources, have a way to check the sources, check the numbers, check what you get as output. Interesting, okay? I told you that there is retrieval augmented generation. And that is what GPT does when you say, hey, tell me about what happened yesterday in Istanbul. Of course, internally the model does not have the information about yesterday. I mean, it happened yesterday. It has not been trained overnight to tell you what happened yesterday. What they do is like, okay, I want to retrieve something from documents that I may choose, but for example, in those cases GPT sees online, I mean, the model can also say, hey, let's go online and see which are the top 5 results on Google, kind of, when I'm saying, hey, I want news about Istanbul yesterday, right? And what you do is like you retrieve, so you find those passages that are most relevant to the question, and you augment, so you put them in your prompt. So you're actually adding those sources, those pieces of information to the prompt as context, and then you generate, okay? So it's retrieval, augment, generation. So the generation then it's like, okay, now that you have all the news from the main Istanbul sources of yesterday, I provide them to you in the prompt. Okay, tell me about what's happening yesterday. Then, you know, the fluency is still there, so it tells you in a nice way whatever has happened yesterday, but the information was not inside of the model. You needed to go outside to take it. And this is the same when you provide your document, your data, whatever thing that you deem relevant, and you add to the context, okay? Well, it's why it matters. It's pretty obvious, because now you have some sources that are you can verify them. Maybe you provide them, so it's stuff that you are interested in. It's your corpus, so it's stuff that you provide. You can even cherry pick things that you want the model to see, and it goes beyond the training, because the training, for example, imagine the model was trained in 2025, and you ask something about an event that occurred in 2026. How come can the model know what happened in the future? I mean, for him, the war stopped in 2025. Again, you go online or you provide some additional information, and now the model knows, okay, I know what happened in 2026. You told me, you gave me some articles, so I know what happens, and I can generate based on the context that you provided me. So this reduces hallucination. Here, I said reduces, it does not eliminate it, okay? But if you ground what you're saying, if you provide your relevant document also, what I many times do is like, okay, I read these 10 papers over the last 2 months, okay? I saved them, but I mean, I already forgot what I read about them, but I know what's the content of them high level. I can provide those papers and say, hey, I have been reading this paper in the past 2 months. The paper is called this, this, and that. The author are those. The DOI is this one. Please provide me a summary of the main ideas that are in this paper. Or if I have my own idea that I have been developing reading those papers, I say, hey, I forgot everything. Please tell me how my idea differentiate with respect to the other paper that I've been reading. Okay, so you provide the context, you provide the actual article, so it does not have to go and search for those in the entire internet. You ground it and say, hey, just these 10, tell me all about it, okay? Still, you need to have kind of an idea of what you have done, so maybe you have read them and you see, hey, I remember this paper, it was not talking about what you're telling me, and so you may challenge the model, or you can try to, you know, change something to get better results, just do one article at a time and so on, but there's always the human in the loop. I mean, these models are not yet ready to, you know, just have a task and do it for us. We always have to be there. For many things, they speed up what we need to do, but still, we really need to be careful on what they give us, okay? This was a case study. We are going to skip it, because otherwise I won't be able to tell you about the fine-tuning and transfer learning that is pretty interesting, but we're just example. We have seen many. I mean, one example was, okay, you have some input, please extract the actors, place, date, location, claim, sorry, and put it in a JSON, and there were some risk. I mean, sometimes you say, hey, please tell me in this paragraph which were the people doing something. Sometimes it advances, sometimes it misses the people, okay? So maybe there were a teacher, a student, and I don't know, a supervisor. And there was a complex paragraph. You ask, hey, which were the actor in that paragraph? A teacher and a student. Well, but there was also a supervisor, you missed it. That happens. And here you could do some kind of classification. You may remember, or may not, that I told you, hey, if you want to do classification, do it with BERT, Natural Language Understanding. Why I'm telling you to do classification with generation? Well, you can do that as well, because you can ask, hey, I have this passage, please tell me what is this passage about. And by generating the next token, you can get the, what the paragraph is about. I still don't think is the best way of proceeding, because you have other models that are casted for that, but you can try. The thing is that sometimes it tells you something that you don't want. So you say, hey, I want sport, politics, and science, and it tells you, okay, this paragraph is about teaching. Well, I wanted sports, politics, and science. Why you are telling me teaching? Because it generates, so it can generate whatever. The other models have a predefined set of labels, so they may be wrong, but at least they tell you what you instructed the model to say, okay? But, I mean, it's not very important. This is something that I want to tell you, okay? We still have 45 minutes, and I think it's the right amount of time in which we can get the idea of what transfer learning is, okay? So, transfer learning tries to reuse the model knowledge, but adapt it to your own task, okay? So it's like specializing the model. It's kind of, you know, I mean, you have been studying for your entire life, and now you have a new task, okay? Well, you don't throw away all the knowledge that you have been gathering throughout all those years, but you kind of adapt what you know in learning the new thing, right? And this is what you try to do with the models, okay? Take the big knowledge that the model has about fluency, about the huge corpus that has been seeing, and customize it for your own need. So, let's imagine, and this is going to be the toy example that we are going to see also in the notebook, that we have protest-related talk, okay? And we want to classify the posts in either be protest-related or not. So it's like a passage, a piece of text related to protest. That's going to be the task that you would like to do to our model. We have okay, that's not really true. Imagine that you have 3,000 tweets, but then for the notebook, also for, you know, not having a too complex task and something that runs quickly, I just made up some, I think, 50 and 50. So 50 tweet-like that are about protest and 50 that are not, okay? This is like a broader context. So if you had 3,000 tweets and you had already somebody or yourself label them, okay, so you are 400 of those that already have, okay, this is about protest, this is not about protest, this is about protest, this as well is about protest. You may leverage those 400 tweets, which are a subset, to make the model better understand your task and use it to classify the other 2,600 tweets. So the idea is that I have a task, I have already read some of them, but I don't really want to read 300 tweets and classify them manually. I want to have a model that specifies in classifying protest, non-protest, and then I want to use it on my original data. So the transfer learning thing is that, okay, I take a model that already knows how to do a lot of things and I specify it for one particular task, classifying tweets, okay? The goal, okay, I have the 2,600 tweets, I want them to label automatically using the information that I gather. Okay, so just some example. They block the square again. We are not leaving until they listen. Well, that's gonna be something related to protest, right? If I just say, okay, a new season of my favorite series drops tonight, I hope that my model tells me that it's not protest related. And the march starts at 6 p.m. by the station. Okay, I want it to be classified as protest. So, there are two stages, okay? The first one, you don't have to do it. Also because if you read there, month of compute, millions of dollars. I don't have millions of dollars, my university not as well, so that's the part that I cannot do. That's the part that somebody has done whenever they provide a language model. For example, even the simple Quen model that we have been using, it takes a lot of computational power and a lot of time to be trained. Because if you think about it, okay, sometimes it hallucinates, there are biases, but it's pretty good at answering stuff. I mean, it's already a good model. It can do a lot of things. The idea of transfer learning is like, well, I have something that it's pretty good at many things. I can ask it to order numbers, I can ask it, hey, classify me the text, I can ask it to summarize, rephrase, do all of this. What if I do a phase that is adaptation? So I take that model that it's good at doing kind of everything, and I try to adapt to a specific task. So your task, your labels, you may have a smaller data set. Here, to do this part, you have to read huge slices of, okay, there is written the internet, but it's really the human knowledge. You need to give all Wikipedia, all the relevant articles, all the good resources that you know in order for it to learn. But then, I mean, you need to see the truth. You cannot have 1 million tweets that are perfectly labeled. You have the 400 that you were able to label yourself. But then you want this model that knows a lot but it's not specific to provide with a specific task and see how good it is in doing that specific task. Can I make it better? Can I customize the model to do what I want it to do? Like the example is it's really simple because it's like being experienced in a scientific field. Okay, so you have been working in a specific scientific field on some topics. Then when you pivot to a slightly new topic, I mean, you don't have to forget all that you have done. It's the contrary. All your background helps being much quicker in learning things. I mean, you have all experienced that, right? When I started my PhD, I was struggling doing any new thing. I was really, I don't know, if I wanted to read a paper, it took me 3 days. Then in the second year of the PhD, it just took 2. Now, I can read it in a couple of hours because I gathered a lot of experience and information, and now I can do new things quicker. But you know, now we take the big model, the pre-trained one, and then we customize it. So we just do the training on what we want to do, and it's the same. So you have studying all your life, new topic, you take just a couple of well-placed resources, and you can do the new task very quickly. It's the same idea. So, what is transfer learning? You need to take this stage 1, all the pre-training that has cost millions of dollars and it's done by somebody else, and you try to use that for your own interest, I mean for your own task, okay? And, well, why should I do like that? Well, the pre-trained model has a lot of things that are really interesting because it comes with fluent grammar and style. We have said that even the silly model that we were trying, they were kind of fluent. Why should I teach again grammar to my model? Okay, you shouldn't do that. You have already something, just adapt it, okay? You have the word's meaning, it can understand context. You don't want to lose that, you just want to specify it better. Of course, what it does not have is what you exactly want. Well, I can ask to classify protest and non-protest. I can try, we will try, but yeah, it's a broad task. I mean, it has not been trained to classify tweets whether they are about protest or not. It's something, it's a lot that you are asking to the model. Is there a way in which I can tweak a little bit the model to do exactly that task? Well, yes, okay. The first one, it's what we have been doing today. It's called zero shot, okay? So you're not doing any training. You're not doing anything. Actually, you're just saying, hey, I have these tweets, please tell me which is the label. And we have been doing that, right? We are kind of saying, hey, I have this particular task, please try to do it, okay? You are an helpful assistance, please summarize the thing for me. You can do that, and it's called zero shot. Did you change the weights? No, we downloaded them, we used them in our program, and we were happy with it, right? Do we need data? We don't need any data, right? You can do it, it's zero shot. So you don't need to collect tweets and label them. You can just say, hey, I have this bunch of tweets, tell me if they are about protest or not. And this is like no effort, because you don't have to do much. I mean, you have to write your prompt that we have seen, it's not that trivial sometimes, but you don't have to have data, but you may get poor performance. You can do few shot. I told you that this would have been something we were about to look into. And what about you have some examples? In the example of the tweet, well, you have already hand-coded some tweets that were, okay, I have the tweet, this is about protest. I have this other tweet, this is not about protest. Well, if I already have that kind of information, I can have a few. Why don't I put it in the prompt? I can say, hey, I want you to classify tweets. I want you to be precise. I want you to provide me just one label. Here there are some examples. And you really put the examples inside of the prompt. That is called few shot, because you have some example ready and you provide them to the model. We are going to see that usually performance improve, because the model kinds of already know what to look into. Okay, so this one, well, I see how the context is in this sentence, and I know that you want that I label it as a protest. And same thing, oh, okay, you are just talking about a movie, it's for sure not protest, you are telling me that it's not protest, I'm gonna label it that way. And then that's going to be the last part that we are going to see mainly through the notebook, that is fine-tuning. Fine-tuning is a type of transfer learning. What you're going to do at a high level, it's like, okay, we took the weights, we downloaded them, we used them, and we were chatting with our model. Now, let's do like this. Let's actually train it. Let's try to change those weights. I told you that those weights were set by a very complex process by somebody, and now we are going to tweak them. Why? Because we want to adapt the model to our task. So we are going to do some learning. That is going to be a bit tough. That is a big leap. Okay? I think that you will not fully understand all the things that I will be telling you, but I really want you to just get the concept. You can do that. It takes some more, training, maybe, to really grasp the internals of it. But the idea is like, hey, I have all these little weights that have been trained to, have all these fluent text and so on. What about I just change some of those to adapt the model to what I want to do? So I provide the examples, so I say, hey, this is a text. I want you to say protest. If you don't say protest, I'm going to just wiggle a little bit the weights in order for you to say protest. I give you this other text that is non-protest and you tell me this protest, no, there's something wrong. And again, you try to wiggle these weights in order for the model to say that, okay, it's not protest. You can do that, and we are going to do that. I mean, it's a bigger leap compared to the prompting that we have done, but it's something that it's pretty interesting. Okay, let's start from the simple things. This you already know. Zero shot. Okay, we have done it so far. It's exactly what we have been doing the entire day. Classify this tweet as protest or not protest. You give the instruction, and then you provide the tweet. So the tweet column is March starts at 6 p.m. by the station. Bring water and a sign. That's the tweet that you need to classify, and then you want the label. Okay, so you say, hey, provide me the label. Zero shot, what we have been doing so far. Few shots, it's like, okay, but I classified already some of the tweets because, I was going through them just to understand what really the task was, and together with my colleague, we have been classifying some of them, so we already kind of know what the task is. So I still want the same instruction, classify the tweets as protest or not protest, but now I say, hey, this tweet, they block the square again, I want you to classify as a protest. Whereas this one, new pasta receipt up on the blog. Well, I hope that the model does it, can recognize it itself. But we have this example and we say, hey, this is not protest. So you're just providing examples within the prompt. It's very easy. But already, even in our research areas, this approach works much better. When, for example, we have some partnership with industrial partnership, when they are able to give us some data, just few, and instead of just, having a high-level task in which you are, okay, classify these things, and for the model that, it's good at everything, but not really good at anything, just providing some examples really helps. And we are going to see, in the notebook, we are going to see that in the trivial case that I will present you, that gives improvement in performances, okay? So same model, that's also something to be thought of, because here we are not wiggling anything. This we are just changing the prompt and we are providing examples. It's like when you do with students. You have a lecture, you present a concept, an abstract concept. Well, if you give a couple of examples, the students may understand better, right? That's the premise. It's again, not a big deal. So that's not really true. I excluded that because Laura was a bit difficult. But we will indeed see an example in which we take one of the models that you have seen with Giovanni, and we are gonna, do some training, changing these weights in order to being better at our protest non-protest task. Okay. So in general, what is the task? You have the pre-trained model and you have some labeled data. Of course, whenever, and this is something that goes back to our first lecture together, whenever you want to do training, you need to have labeled data. So you have to be able to say to the model, hey, this is a dog. You need to have the label already on the picture. You take another picture, you have, okay, this is a cat, and you go on with this. So the model learns from making mistakes. It's like children when they need to learn. And here you need, okay, you have the pre-trained model, you need label data, and then you tweak the weights in order to specialize the model, and you're gonna have your own model. The good thing is that after that you can save those new models, and that is gonna be your model. Okay, you have it locally, you have it on your server, but that model, those weights are gonna be specified by you, and you can reuse them whenever you have the same task. Okay, let's stop just talking. Let's see a little bit how things are done, and if it's really true what I'm telling you. Yes?
Good question. What is a good number of, for example, examples for fine-tuning?
Depends. I mean, these numbers are indicative because also with, especially when you're doing training, depends on, for example, the task that you're doing. Imagining that you're doing classification and you have 3 classes and you have 300 labeled examples, but for one class you just have 2. It could be because you are looking through the tweets and you just find 2 tweets that are talking about sports. So you have 300 data, but just 2 about sports is going to be really bad, your classifier on sport. So that's just to give a ballpark. If you have, if you don't have anything, I can assure you, you need to do 0 shot. If you don't have labeled data, you need to go with that. Okay, you cannot do anything else. If you have just something, just few in the order of 10th, you can put them in the prompt. It's like saying, okay, I have almost nothing, but that piece of information may be valuable, I give it to the prompt. I give it to your context, and maybe you can understand a little bit more. Then, if you have order of hundreds or better 1,000, well, at that point, you can try to do fine-tuning, okay? Less than that, you are gonna get something that is not ideal. We are gonna do something that is not ideal indeed, because in the notebook, we are gonna have, I think, kind of 80 examples, and we are going to do fine-tuning, and that's really a stretch. But it presents you the idea. I mean, everything works fine, and let's say the process is exactly the same. Okay, other questions?
No, it makes sense. Especially, for example, when we are doing the coding for the qualitative data, let's say we have like 15 interviews, and we may code 5 of them, and we can have our patterns that we want to see, and then maybe later, after we train the model, AI can do the other 50 for us, and if we are missing something.
Yeah, but again, the numbers are a bit small. You should be talking about, I have done 500 coding, and I have
like we have 15 interviews, and then
it's not,
5 of them. Okay.
You can just do few shots. I mean, it helps already, because, for example, if you say, hey, I want you to do some coding, and I have these examples, so the model kind of understand the structure that you want, that can improve the result that it gives you. So this few shot is going to be your case. If you really want to do fine-tuning, you need to have more data. Because one problem with the model is that when you start touching the parameters, if you have too few data, the model has so many parameters that it memorizes your data. So when you use it in the real world, it's terrible. It never works. So it's really good in the data that you've told. It's like, you have a student that it's lazy but has a really good memory. And you provide some, whatever piece of information to the student, and the student has a visual memory and memorize those. Whenever you ask a question that was not exactly in the textbook and you need some reasoning, it fails. Here is the same thing. if you don't have enough training data, the model can just memorize the thing. It seems to you that, oh, it's amazing, I get 100% of accuracy, I must be the best. And then you try it in the real world and you get 0 or close to, and you're like, what went wrong? Just memorizing. So when you have few things, go with few shots. It's already helping because really, I've seen it with first hand that when you provide examples, then the model say, okay, I'm kind of understanding the structure that you want. I see that, okay, in this case I need to do this thing. I mean, it's really helpful, but don't overshoot with fine-tuning if you don't have enough examples. Okay, so now we are gonna look into our last notebook, okay? And the coding part, it's a bit tougher than the other, and there are some concepts that are advanced. So this one, it's gonna be easy. We have been doing that the entire day. You know now better than me, I'm pretty sure. This one, it's a new concept, but I mean, from let's say a practical point of view, it's not that difficult. You kind of just add the examples in the prompt. This one, we are fine-tuning a BERT model. That's advanced. You're gonna see some things that I will try to make you understand, but I'm pretty sure you're not gonna understand 100%. And I decided to do it anyways because I want you to get exposed to the idea. Then later on, if you really like, this kind of computer science thing, you may dig deeper and understand it better. And then maybe you come back to the notebook and say, okay, now I can really understand what you're saying. But let's cut the words and let's go with our last notebook, okay? So, we skipped the third notebook because we don't have much time. There was just, yet another example. It was cool to see how it worked, but I mean, you got the ideas by now, okay? This part, it's much more interesting. So, transfer learning and fine-tuning. So, let's imagine that we are working with a miniature version of what I told you. I told you, okay, we have 3,000 tweets and 400 hand-coded tweets with a label. Well, just for the sake, of teaching, let's imagine that we have 60 tweets and 20 held-out tweets. Well, we already start with something that I never told you. What is held-out tweets? Well, imagine this. Is exactly the example that I told you with the guy, the student, that was able to memorize everything. So, if you have such a student, what you shall do? You shall have, let's say, question and answer that you have already prepared on your table, and you shall give just some question and answer to the student, because if you give all of those, he will memorize everything and will know everything, but he did not really understand. So what you can do is like, hey, I provide this guy just 80% of the question and the answer. So that guy is gonna struggle on the new 20 answer that you and question that you left apart, right? Whereas another student that maybe has not a visual memory but really understand the concepts, okay, it's gonna go through the papers, reads them, understand the content, and when you give a new task, it's gonna say, hey, but I understood what you told me before, and now I can, reason by my own and tell you the answer to the thing, right? So here you need to do the same. You need to have some tweets, okay, so you have a tweet about protest and you say, okay, this is protest, and you can use that for training, but then to see if your model really learned something, you need to have some tweets that the model has never seen. Otherwise it's cheating, because you give, both the question and the answer, all of them to the model. Of course the model will know how to respond. It's like when you do exercises in class. You do some exercises, but yet the exam, you change it a little bit because you want to see, okay, did the guys that came to my class just, memorize whatever I told them, or are they able to make the leap? Here is the same. So you take 60 tweets and you use them for training, and you take 20 that are gonna be, okay, now that I train my model, is my model able to recognize these new tweets? Okay, it's just that.
Is there a certain rate between training and control?
If you need to have?
Because there's a three times difference, 20 and 60. achieve a certain rate?
Yeah, well, what usually you, I mean, the percentage you can choose it, but it always needs to be skewed towards the training, because you should keep as much as possible in the training, because the more data you have, the better it is, and then you just need to leave a percentage out, okay? So usually what you do is like doing 70-30, or 80-20, or 60-40. I mean, that's really up to you. That's a design choice. I mean, there's no golden standard there. Usually, I mean, personally, I usually do 70-30, but it's rather arbitrary. If you prefer to do 80-20, it's fine. If you start doing 95-5, okay, people are gonna complain. Or if you do the opposite, you take 20 for the training and all the rest for the test, people are gonna say, hey, why are you doing that? You should, I mean, why you have just few examples in the training part? But it's really up to you, skewed towards the training. So we are gonna have 4 experiments, the 0 shot, and that's like build a prompt and ask, hey, please tell me if this is protest or not. Then we are gonna do the few shot, so we are gonna put, hey, by chance, I have some examples that I can provide you. I'm gonna put them in your context. Are you gonna be better? And then we are gonna change the weights, okay? It's really gonna be just 15 lines of code, really messy, not really clear what's happening, but there what's happening is like, you give the model a tweet, okay? And you give the label. So you see, hey, model, what would you say this is protest or non-protest? You see the output. And if it gets the output wrong, you start wiggling a little bit and changing the weights. That's the overall idea, okay? So let's start from something that we are, I mean, we are already trained with. I need to connect with the GPU. Why it's not working? Wait 1 second. So. Yeah, anytime it changes the language, but now we know where to look at the GPU thing, right? So, okay, this is a problem because I cannot connect to the GPU, because probably I use too much GPU these days preparing the lecture, but it doesn't matter too much because we have a backup plan. You can follow along, I think, if you don't get prompted that. What I need to do now is take my notebook that I ran this morning to check that everything was all right, and I won't be able to run it with you, but I can show you which results I got previously, okay? So it's not ideal, but you can follow along. I mean, if you don't trust me, you can run it yourself. You shouldn't have problems with the usage limit, and you can tell me, hey, you are telling us something that is not true, okay? So, yeah, okay, see, I mean, I cannot run it, but here I was running it on CUDA, for example, this morning. So, no problem, you can run it, so please run the first cell here. This is just a usual installation of packages. Then here we have some setup, we are fixing the seed, we know now what it is, and then we are selecting whether we are working on GPU or CPU. Now, let's look at the data. I told you this is like just a simple example, and we have synthetic data in which we have protest tweets, okay? So they block the square again. We are not leaving until they listen. And we have 40 of those, I think. And all of these are gonna be tweets that are related to protest, and we know that. So we have a label for all of those. All these are protest. Then of course I told you there are also some non-protest tweets, and we have another list, okay? This is kind of our data. And if we were to go through those and label them, I mean, it's boring and it takes some time, but we have them already labeled, and we can leverage the fact that we already know whether they are protest or not. So run this cell as well, and it's gonna just tell you, okay, the training set, so the part that we are gonna take for training, remember that kind of 80%, it's 60 tweets. Yeah, I told you that you need at least 300, true. but you know, here we are just making an example, okay? It's not the best thing. If you just have 60 tweets, better go to with zero shot. We are going to do fine-tuning as well. The procedure is going to be the same, but we would have needed to have much more tweets with the label, okay? So, can you run it, or do you get problems in GPU usage as well? Everything's fine, okay, so it's just me. I ran too much this morning, sorry. Okay, so let's follow along. The first experiment was zero shot, not training at all. You already know it. So, well, we are using a slightly different model, okay, instead of the Quen. This is a little bit smaller and it's faster to run, but I mean, you can also use the Quen of before. And here, you are just want to do, where is it? Zero shot classification. So here, the way in which you tell the model what to do is slightly different. Here you say, hey, I want to do zero shot classification. And the labels, so the possibilities that you have are just two. One is protest or demonstration, and the other one is everyday life. So, I mean, it's still protest, non-protest, but in a slightly different way, okay? And so, you can try to run it. You should get something that is really similar to this one. Did it go? Do you have 70% of accuracy? So it means that on those tweets that you left aside and you tried the zero shot approach, so it's kind of saying, hey, zero shot, just tell me if it is protest or everyday life, you are right 70% of the time. Well, it's not that bad, because 70% it's not 12%, but still, we would like something in the 90% figure, right? So, for example, here there are a few predictions, and you see that the first one, the model get it wrong, okay? So, we hope that with the few shots, we can skip this part. This is just saying, if you slightly change the label, you may slightly get different results, okay? So here I told you the candidate label are, okay, a protest or demonstration and everyday life. Well, those things are chosen by you, and if you change them, you get different results. Here, I made an example. Okay, let's imagine that we would like to slightly change things. So we say protest and non-protest, and then a protest or demonstration and everyday life. So this is the one that we actually used, and see the first two approaches, so protest, non-protest, protest or demonstration and everyday life, we got exactly the same result. So, okay, to that the model is insensitive. But if we say political collective action and ordinary daily activities, well, we start getting something completely different. So you have to be mindful on the words that you're choosing, as always. But you know, even if you went with the good old protest, non-protest thing, you were more than okay. You were doing as good as the other labels, okay? So, but that is what we have already done, okay? There's nothing new. Now, yeah.
The accuracy become less because the model become more sensitive or not to that?
In this case, because you are more specific. I mean, here, political collective action is actually more specific than saying protest, non-protest. So the model really labels as the other one also things that are actually protests or demonstrations. So you really need to choose the wording right. I mean, if you want protest, non-protest, go with that. If you want something else, try to be specific with what you ask. It's you know, the mantra of today. When you want something specific and your ideas are clear, you need to be clear with your word. And then the model maybe behaves decently, okay? If you are, if you say something that it's more specific or broader, then the model can get confused, okay? It's all about that. It's like, you know, when we were making a prompt that was a little bit general, the model started saying very general things. It's kind of the same idea as well, okay?
How many levels does this have?
Sorry?
Rather than giving example defining levels, like what we mean by qualitative collective action, this kind of definitions, like memos in qualitative.
Yeah, I mean, it's like when you say, before we saw some example in which we say, hey, you are a helpful assistant, tell me if it's sport, politics, or something else. Those are the labels that you're choosing, okay? If you change that, of course, you're asking different things. So it's really just that. If you're asking the model to say, hey, protest, non-protest, or if you're asking something that is much more specific, I don't know, feminist protest versus non-protest, you know, you are changing completely the task itself. I just wanted you to show that the labels are very important. I mean, it goes without saying that if you ask the model to classify things slightly in a different way, of course the model gonna do a slightly different task, okay? Okay, so fortunately now we go back to our Quen model that we know very well. So here we do kind of the same thing that we were doing before. The only difference is that, like, on top of the prompt, okay, we also provide, you see here, I say few shot. Here, I mean, this is a complex way of writing. Take the first 6 examples in the data, okay? Here it's just saying, okay, if you were to copy pasting the thing, you would just take the first tweet with the label and put it in the prompt. The second one with the label, put it in the prompt, and go on and go on till the 6th one, okay? And then you say, okay, my user message is like, you label tweets. Here I have been a little bit concise. I could have, you know, made a little bit better prompt, but the idea is that you label tweets. Answer with exactly protest, non-protest. So I'm specific about the output. And then here I provide all the examples. So I give the first 6 examples, and I hope the model getting to know what my task is will have a little bit better performance. And I mean, here, you know, is the thing that we have used before. We have some function that takes all this context and give it to the model, and the model provides you the output. Well, the output here, okay, it's slightly better, okay? So instead of 70%, we got 75%. We didn't do anything very groundbreaking, right? We were just having some examples there, and we provided the model with examples. So this is yet another way of improving your prompt. If you have some examples that you can say to the model, hey, I'm doing this task, I want to do it in this way, put them. You get some kind of accuracy benefit, okay? Okay, now it's the big leap, okay? I provide you the code, and the idea, high-level idea, is the one that I already told you. It's like tweaking a little bit the weights. But what I show you, it's going to be very confusing. But since we are toward the end, it's acceptable to be a little bit confused. So here, really, do not look at the code, okay? Because this is a little bit technical, okay? To do that, you need to wrap the tweets in a format that the model can see. Then you need to train it, and we kind of never trained it, right? We always use some models that have been trained by somebody. So this part, it's not that difficult, because you see there are a few lines of code. You have a trainer function that probably trains the model, right? And there you provide, of course, the model, and you provide the tweets. So you had the training part and you had that verification part. Somehow you have a function that takes the training, so you have the tweets and the label, tweet label, and changes the weights for you. I mean, it's important that you just get that, okay? And, well, you do some stuff, shady stuff that we don't really understand, okay? This is even more confusing. What is that? Let's forget about that. We can talk about it more later, but I mean, here you really need to know what it's training, why you need to keep a little set for verification, for validation. And here you see the performance that is changing over time while we are training. Very confusing. But at the end of the day, I want you to see the head-to-head comparison between these three approaches. Well, of course, when we were doing zero shot, we were not using any data, right? We were just asking the model, please tell me, okay? And we were getting 80%, 70%. Here it should be 75. Remember that it's 75. But here, when we were fine-tuning the model, well, we were using 60 examples, but we were getting almost all our tweets right. Still, this is not the perfect computer science thing because you have too few examples to actually do fine-tuning. But if you were to have many more tweets, you would have gotten much stronger pipeline and these kind of good results. Okay?
Actually got like 100% for fine-tuning.
Okay, when you get 100%, it can be, but that's always fishy. I mean, if you want, I would like to try to tell you a concept that it's really computer science. I think you can get the idea, but it's kind of difficult. Well, I know that you may get 100% of accuracy, but when you get that, you need to start getting worried about that because it's too good to be true, right? So, one thing that I told you before is that these models are lazy and are able to memorize stuff. So when you get 100%, you need to start suspecting that they did not learn the patterns by they really memorize your dataset. It's just a student that can memorize whatever you put in front of it and memorizes it. You see here, there are these two curves, okay? One gets to 100%, and probably is what you are seeing. And that's the training curve, okay? Usually, when you train, you need to see, hey, how good am I doing on the data? How good am I doing on the data? And while you train, that curve, it's gonna increase because you're getting better. Like you're training, you should learn something. Like if you're learning, you're gonna get better. The problem is that you get to a point, and here you see, because here we are comparing what are the performance on the training data and what are the performance on the test data. There is almost always a point in which in the training you keep getting better, but what you're doing is memorizing the training data. But if you look at the test, well, at some point you get worse. So you should stop, okay? But again, this is first year of master students in computer science. So getting exposed to the idea, it's fine. We are at the end of the session. We got something that is a little bit different than what we have done so far, but I think that this level of abstraction is the most that we can do. But again, I think that today you came without knowing what fine-tuning was, and now you kind of got the idea that you need to have more training data, because if you have just a few, that's not really learning. And you got the idea that if you have a specific task, you kind of act on the model. That was the first time ever that we acted on a model. All the time we were taking the model from somewhere and using it to doing something. That's fine. But today, for the very first time, we took the model, we changed it a little bit for our task. I mean, it's enough that you know that that's possible, okay? And maybe in the future, when you know you're gonna get all passionate about the computer science details, you're gonna get over it and really understand it, okay?
I was wondering how fine-tuning is different than machine learning.
No, it's a machine learning technique. Well, usually in machine learning you start with, again, a model, but you don't have the pre-training phase. Like I told you, what you want really to do here is like, okay, somebody took this model and make the model learn already. I want just to tweak it a little bit. When you do machine learning, you start from, okay, I don't have nothing, I have a model that is blank, and I need really to make it to learn from scratch. Indeed, you say training from scratch. Here, you just tweak a little bit, because the model already knows semantics, already knows the context, or is already fluent. You just have to tweak a little bit in order to do protest, non-protest thing, okay?
There isn't the 100% accuracy. Could it be as a result of data leakage or something?
Yeah, here is overfitting. Here it's like you memorize the data, and not only that, the examples that we had, those were synthetic data. So it was not really tweet that were labeled by a human, and those were really similar. So you were kind of memorizing the patterns in the training and using them in the test. But you know, the thing here is that there, where is it? In this part of the code, if you were to put real tweets, I mean, you collect them online, you put tweets, and you run the same notebook again, you're gonna get decent things. This is, you know, it was just not to go on X to get Twitter and label them. It was just easier to do that. But the idea, it works. Here, if you have your label tweets that are about, I don't know, protest, non-protest, and you put them there and you run it, then you got interesting things, okay? Okay, yeah?
Assuming that you got the tweet and you don't have any labels, you don't have any sample to train the data, is it possible for you to just ask the vet, for instance, to ask it to label it for you?
Yeah. That, if you see here, it's a zero shot. Okay, if you also see the summary table at the end, which is right here, you see that the experiment with a zero shot, how many label example did use? 0. But there, remember, when you ask the LLM to label the things for you, you have to check what it tells you. For example, with, you know, repeating the same question and seeing how many times you get the same label or varying labels, because that gives you an idea of, okay, how unsure the model is about that thing, okay? So you can definitely do that, and I mean, most of the people do that all the time, but you have a way to kind of validate. Either you can do either what I told you with repeating the experiment, or you can do also something else. Like you let the model do it for you, and then out of the 1,000 tweets you have, you take 100. Okay, 100 is way less than 1,000, and you look at how model performed. If you see that the model did pretty well in 85% of the example, you can kind of assume, okay, I can trust it. If you see that, the model was right 10% of the time, use a bigger model, change the prompt, something went wrong, okay? But you need to do that evaluation step.
If we get 1, and when we run all the codes, we get 1 for the accuracy. I don't know why we have this difference from yours. If we get 1, what will be our next step? Like trying our model on a different data set?
If you get 1,
yeah.
In fine-tuning or in another thing?
In fine-tuning.
Well, if you really get 1, you either add too few labels, like in this case, you add no, it's not labels, you're right. Training data labeled, okay, because we had just 60 examples. I told you in a slide, if you have less than 300, don't do fine-tuning, okay? Do few shots, but not fine-tuning. What you could have, I mean, another possible problem is that you are overfitting. So you got 1, but actually you are just memorizing your data. So you have enough data, but you just got to, you know, memorize what you have in the training. Another problem could be that, well, and this is the data leakage that your colleague was saying, is imagine that for some reason your data got duplicated. So you have your tweets, but you had 100 tweets, and for some reason you duplicated them, you have 200, you don't recognize that each tweet appeared twice. and you train, but some of the training example also get in the test, right? Because imagine you have 100, they are duplicated, you show the model the tweet and the label, but then you ask the same question again when you test it, and then you get 100, because the model has already seen those, and it's perfectly fine with that, and that's data leakage. So all these are things that, you know, are well-known problems in computer science, in machine learning, but when you see one, always ask, yes, you never get one. I mean, my experience is that in some cases you need to fail. If you are good in all of them, no, I don't believe you.
So is there a way that you can do some post-analysis, like text similarities before you start the fine-tuning?
To do what? Like not to have the same data in training and test?
I mean to confirm that the data you want to train and test with is okay for the fine-tuning. Is there a way you can do some post-analysis of the...
Yeah, maybe, that's a good question. One thing that you can do is like looking at the words and the length of the tweets, for example. If they have kind of the same length in the train and in the test, it can be good. If you see that they have too much overlapping vocabulary, so they use the exact same words in the train and the test, maybe it's not such fair comparison. I mean, your model is just learning the patterns that are in both. But I mean, it's a little bit more advanced if you want to do that.
Are there models that can text this in the text similarities, or maybe whether the sentences have some common theme amongst them?
Yeah, I mean, there are,
like in terms of numbers.
There are some, but there I really don't know anything. There are some ecological measures of diversity, for example. You can try to use them. One thing that we usually do is like try to check the co-occurring words. So if you have, you know, 3 words that always appear together and you have them in both the train and test, maybe the train and test are too similar. I mean, you are kind of teaching something and asking the same question. But there are 1,000 ways to do that. And all of them look at some slightly different aspects. So you may combine them together, okay? Okay, yeah?
In machine learning, the concepts like the cross-validation, since that fine-tuning is a similar process, if there's something like that,
yeah, here at some point I showed you the accuracy and test curve, what you really want to do, but I mean, now I'm just mentioning him for him because I know that probably he has some background on that. What you usually do is like, you take your data, you divide them in train and test, and then what you do, you divide the train in train and validation. You use the validation to see if you are doing overfitting, if your parameters are correct, and so on, and then you test. But here I just wanted to make it simple because it's already difficult, you know, for the first time to see train and test. I didn't want to make further, but definitely here in fine-tuning you have to do train, validation, and test as well.
But still, there's like more advanced ways to, as the machine learning, there's like more advanced ways to maximize the profit from the data that we have, like cross-validation, for example. There is that.
Cross-validation, I mean, that is something that you, I don't...
I mean, like there's more advanced ways to benefit from the data that we have. But
well, that is more about optimizing the parameters. For example, here, where is it? At some point, I cannot find it any longer. You have all the parameters that are fixed. Usually what you do is like, when you do cross-validation, you take your data, you split it in train and validation, you see which the parameters are better, and then you do it again, splitting differently the data in order, you know, it's kind of avoiding to use both at the same time, but keeping always apart on the side and using them to training, and then, but that it's, you know, it's more advanced because, okay, you already kind of know how the machine learning pipeline works, and you would like to have the best parameters that, let's say, give you the best performance for your model. No, definitely you can do like that also in fine-tuning. You take a part and then you validate on the other, then you do a different split and you go on, you go on and on. Yeah.
Franco, maybe you just talk about this. Where does the reg process fall among those?
The RAG
learning RAG.
in the model that in the transfer learning?
Yeah.
No, it's not related to transfer learning. Transfer learning is like changing the model so that you can customize it to your need. Retrieval augmented generation is like enhancing the context. So you're still having a prompt, but you would like to give sources yourself or automatically connected from the internet to better inform your prompt. Those are two different things. Okay, so I would say that we are done, and thank you for the attention. It is always a pleasure to be with you and try to explain you something. I really like the interaction, and I think we can start going to dinner. Thank you so much.